Every night, when Earth grows quiet and our thoughts loosen their edges, countless distant planets continue circling their silent suns. Some of them are larger than our world, wrapped in thicker skies, shaped by deeper gravity, and coloured by atmospheres we have never breathed. These are the super-Earths, alien worlds that drift beyond the warm horizon of human experience, waiting in the cosmic dark like gentle questions we have not yet learned to answer. Welcome to AstraFlow. Here, science drifts like starlight and curiosity becomes calm. Tonight, let your thoughts slow down, your breathing find its rhythm, and your mind float through wonder. Before we begin, I'd love to know where you're listening from. Are you lying in bed under city lights, or watching the stars from somewhere quiet? Tell me in the comments. It's always peaceful to imagine the AstraFlow community scattered across the world, drifting together through the same sky. And if this calm journey brings you peace, you can gently support AstraFlow by liking this video or subscribing. It helps this little corner of the cosmos keep glowing. Now, settle deeper into your pillow, let your shoulders soften, feel the slow tide of breath rising and falling, steady as an orbit. Tonight, we drift far beyond the familiar patterns of our own blue world. We journey to planets heavier, brighter, quieter, stranger, worlds shaped by forces that echo Earth's design but unfold in new, surprising ways. We'll breathe through their atmospheres in imagination, walk across their distant seas in thought, and watch alien sunsets tinted by colours no human eye has ever truly seen. Together we'll explore what it means to call something a world, and how many different versions of home the universe may offer. We'll wander through calm descriptions of super-Earths, mini-Neptunes, tidally locked planets with one side forever bathed in suns, and ocean planets without a single shoreline. And as we float through them, slowly, gently, you may begin to feel your own mind soften into a drifting rhythm, a quiet orbit that mirrors the calm movements of these distant spheres. So let's begin tonight's voyage into the quiet story of super-Earths and alien worlds, where gravity deepens, colours shift, and the imagination has room to breathe. As we drift deeper into the quiet of tonight, a gentle question rises like a slow tide. What makes a world feel like home? It seems simple at first glance. A world is a place with ground beneath our feet, air in our lungs, and a sky that bends softly above us. Yet the more we look, the more delicate the answer becomes. Home is not only made of rock and atmosphere, it is shaped by balance, by gravity that supports our bones without straining them, by light that arrives in daily rhythms, steady enough to guide sleep, wakefulness, and memory, by temperatures that hover in the narrow band between freezing and burning, allowing oceans to form and life to unfold in gentle layers. When we imagine super-Earths, worlds larger, heavier, and older than our own, this question changes shape. Suddenly, the ingredients of comfort stretch into unfamiliar territory. A stronger gravity pulls downward with persistent strength. A thick atmosphere bends light into uncommon hues. A distant sun, cooler or hotter than our own, shapes the sky into shades our eyes cannot yet picture. Could such a world still feel like home? Or would it feel like something entirely new, as though the universe were quietly reminding us that comfort is adaptable and belonging is wider than we think? A world becomes home when its rhythms match our own, when its days drift in predictable arcs, when its winds speak in soft patterns, neither restless nor still, when water in whatever form it chooses, liquid, vapour, ice, moves with steady grace. Life, after all, is nothing more than chemistry taught to follow a rhythm, and rhythms arise from the shape of a planet, the pull of its star and the age of its sky. But perhaps there is something deeper. Perhaps home is not only external, not only landscapes and atmospheres. Perhaps home is also the feeling of safety that settles in our chest when we understand the world around us, when we know the cadence of rain, when we recognize the fading blue of dusk, when the temperature at night falls in a range our bodies have learned to trust. If we were to stand on a super-Earth, with gravity pressing more firmly against us and the sky tinted in copper or violet, would our senses adapt? Would our inner rhythms shift to match the new world beneath us? In the stillness of this moment, with your breath steady and your thoughts drifting gently outward, imagine that first quiet step onto a world not shaped for humans. The ground is familiar in some ways, solid, textured, supporting, yet different in others. Your weight feels doubled, but not painfully so. The air is denser, giving every inhalation a subtle resistance, like breathing through warm mist. The sky glows in shade softened by thick layers of foreign gases. Nothing is threatening. Nothing is loud. The world simply exists, calmly, waiting. And as you stand there in imagination, the question settles again, softer than before. What makes a world feel like home? Perhaps the answer is simply presence. The willingness to listen, to observe, to breathe slowly beneath an unfamiliar sky until it too becomes familiar. Before we drift farther into the cosmic sea, it helps to understand what scientists truly mean when they whisper the term super-Earth. Despite the name, these planets are not larger versions of our world in every sense. Instead, the term refers mainly to their mass, worlds between about 1 and 10 times heavier than Earth. Some may be rocky, like our home. Others may be wrapped in thick atmospheres, blurring the line between solid ground and gaseous layers. A super-Earth can be warm or cold, calm or volatile, oceanic or mountainous. The phrase is not a promise of similarity, but an invitation to imagine possibility. In many ways, a super-Earth is a reminder that the universe rarely repeats itself. Two planets of the same size can carry entirely different personalities. One may hold oceans deeper than any trench on Earth. Another may have continents shaped by slow, tectonic rhythms under greater gravity. A third may be almost Earth-like, save for a sky tinted by exotic minerals suspended in the air. The term super isn't meant to imply better, only bigger, heavier, and potentially more stable. As you breathe slowly, let your mind picture these worlds forming in silence. A cloud of gas swirls around a newborn star, dust grains drifting like tiny seeds. Over millions of years they collide, stick together and grow. A planet forms, dense and patient. Its gravity strengthens, its surface cools. Rain falls for the first time perhaps, or never at all. Layer by layer the world reveals its nature. Some super-Earths may be so thick in atmosphere that sunlight arrives only as a soft glow. Others may have bright surfaces of reflective rock, scattering their stars' light into shimmering halos. Because they are larger than Earth, many super-Earths hold their atmospheres more tightly. This makes them promising candidates for hosting life, at least in theory. Atmosphere's moderate temperature. They shield surfaces from harsh radiation. They allow water to remain in liquid form across long stretches of time. In the grand cosmic game of habitability, a stable, long-lived atmosphere is one of the most precious gifts a world can offer. And yet, super-Earths also present mysteries. Stronger gravity can flatten landscapes, making mountains wide and low. Oceans may feel heavier, their waves rolling slowly under the weight of deeper pressure. Weather systems might become more powerful or more muted depending on the chemistry of the sky. The ground beneath your imagined feet might feel reassuringly solid or strangely resistant, shaped by minerals compressed beyond anything Earth has produced. Scientists find these planets fascinating not because they resemble Earth, but because they expand our sense of what a planet can be. In the last few decades, thousands of exoplanets have been discovered, and super-Earths turn out to be surprisingly common. They orbit stars throughout our galaxy, especially smaller, cooler stars where planets can form closer in. Some lie in the habitable zone, that quiet ring around a star where liquid water might flow. So as you continue to breathe softly, and your body settles deeper into stillness, imagine the vastness of this possibility. Countless worlds, heavier than ours, drifting through the dark, each one with its own sky, its own chemistry, its own quiet story waiting to unfold. Tonight we will explore some of them, gently, slowly, letting each imagined step guide us deeper into wonder. Imagine for a moment a world 5 times heavier than Earth, not 5 times more massive in spirit or complexity, but literally 5 times our planet's weight. A sphere of stone and metal so dense that gravity presses down with steady, patient strength. As you breathe in, feel that imagined gravity settle gently across your chest, not harsh or overwhelming, just a quiet reminder that this world is built from more material than ours, shaped by deeper pulls and slower motions. On such a planet, everything feels anchored. Everything moves with intention. A super-Earth of this mass reshapes the landscapes we know. Mountains cannot reach the sharp, dramatic heights of the Himalayas. The planet's gravity would soften their silhouettes over time, pulling peaks downward, spreading them wider. Valleys would be broader, smoother, carved not by rushing rivers but by the weight of rock pressing on rock. The land would seem gentle from above, a landscape smoothed by a firm, constant hand. Imagine standing on such ground. Your body feels heavier, not painfully so, but noticeably. Each step is deliberate. Each muscle responds with more effort. Walking becomes slow, almost meditative. On Earth, we're used to the sensation of lightness, of motion that comes easily. Here, motion has meaning. Even the wind feels different, moving through a thicker atmosphere. It presses against your skin with a soft density, like warm water flowing around your limbs. The oceans on a world 5 times Earth's mass would behave differently too. Deeper gravity creates deeper basins, and water settles with a heavier presence. Waves roll more slowly, their crests lower and smoother. Picture an endless shoreline where waves come in not with sharp white caps, but with long, quiet breaths. The surface glimmers less wildly and more steadily, reflecting the muted sunlight of a star filtered through dense layers of air. Temperature patterns would shift as well. A heavier world often holds onto its atmosphere more securely, allowing heat to distribute more evenly. Such a planet could have milder temperature swings, long-lasting climates that evolve with patience instead of urgency. Warm regions stay warm, cool regions remain cool. Weather moves in slow rhythms shaped by the planet's weight. If life existed here, it would grow differently. Plants might grow low and wide, hugging the soil to resist gravity's pull. Creatures might move with strong, sturdy limbs, built for powerful but unhurried motion. Wings, if they existed at all, would need to push against thick air and heavier pull, meaning flight would be rare. Perhaps reserved for small, gentle gliders drifting between dense layers of atmosphere. And yet, despite these differences, the world would have a peaceful beauty. A horizon softened by pressure and light. A sky coloured by minerals held aloft in the atmosphere. Clouds drifting slowly, like enormous contemplative thoughts. A sun shaped by distance and haze, glowing in copper or pale gold. As you breathe out, imagine the calmness of such a place. A world where everything is grounded, everything moves with intention, and gravity encourages stillness. A world heavier than Earth, yet somehow soothing in its steady embrace. Tonight, we continue our journey through such worlds, letting their quiet physics deepen our sense of wonder. On a super-Earth, gravity is not just a number, it is a presence, a quiet companion that shapes every movement, every gesture, every breath. Imagine stepping out onto such a world where the pull beneath your feet is twice, perhaps 3 times stronger than the one you feel on Earth. The ground greets you with a firm steadiness. The air feels thicker, almost textured, brushing against your skin like warm mist. Even your thoughts seem to move more slowly, mirroring the world's patient rhythm. Walking here is gentle work. Each step requires a subtle negotiation with the planet itself. Your foot lifts, but only just. The arc of the step is low and deliberate. When you place it down again, the contact feels full, more complete than on Earth, as though the planet is acknowledging your presence. In this heavier gravity, you cannot hurry. The world invites you to match its pace, to move with care, to feel the way your muscles lengthen and shorten in a slow, deliberate dance. Under a stronger sky, your posture shifts. You stand slightly closer to the ground, your centre of gravity drawn inward. Movements that would feel effortless on Earth become gentle exertions, not strenuous, but weighted, as if each action carries a quiet meaning. Even your breath becomes a collaboration with the world. Dense air fills your lungs with a comforting resistance, like breathing through a warm scarf. Exhaling feels slow and calming, a steady release that mirrors the planet's deeper rhythm. Above you, the sky stretches out in colours shaped by its heavy atmosphere. Thicker air scatters light differently, filtering starlight into softer hues. The blue might be deeper, richer, almost velvety. The sunset might drift into shades of copper, indigo, or pale green, depending on the gases suspended in the air. Clouds move more slowly here, pushed along by winds that feel gentle despite their underlying strength. Everything moves as if slowed by thought, a world reflecting on its own existence. The soundscape changes too. On Earth, air vibrates easily, carrying voices and wind songs across open fields. On a super-Earth, thicker air softens those vibrations. Sounds feel closer, warmer, wrapped in a natural hush. A whisper doesn't travel far. A distant noise becomes a gentle blur. The world seems to lean inward, encouraging quiet, inviting contemplation. If life exists beneath such a sky, it might have evolved to move with this steady rhythm. Strong limbs, compact bodies, slow strides. Creatures built not for speed, but for balance. Plants spreading wide to anchor themselves, leaves shaped to push gently through dense air. Everything adapting to weight, to pressure, to atmosphere. Not struggling against the world, but partnering with it. As you picture this stronger sky above you, let your own breath slow to meet its rhythm. Feel the gentle pull of gravity in your imagination, grounding you, inviting you to settle into your pillow or your bed. Let the heaviness be comforting, a reminder that every planet, every world, offers its own version of calm, a calm shaped by physics, a calm shaped by time. Walking beneath such a sky is not tiring, it is centering. Each step a reminder that weight can be a form of peace, and that gravity, in its quiet persistence, can teach us to move slowly, breathe deeply, and feel fully connected to the world beneath us. Imagine lifting your gaze on a distant world, a super-Earth orbiting a star unlike our Sun, and seeing a sky shaped by colours no human eye has ever truly known. Here, the atmosphere is thicker, richer, infused with gases and mineral particles that bend light into unfamiliar shades. Each sunrise becomes a quiet performance of physics and poetry, a slow unfurling of hues that feel both alien and soothing. On Earth, our sky is blue because molecules scatter sunlight in a particular way. But on a super-Earth, the atmosphere might contain methane, sulfur compounds, metallic dust, or vapours from exotic oceans. These ingredients reshape light, scattering some colours and absorbing others. The result? A sky that glows in emerald tones at noon, or soft lavender during the long stretch of evening. Some worlds may show a pale peach haze, gently reflecting the warmth of a cooler, redder star. Others might reveal skies so deep they appear almost violet black even during the day. Imagine standing there, letting these colours wash over you. The light feels textured, as though it has weight. Every ray travels through dense layers of air before reaching your eyes, softened by scattering, warmed by minerals suspended in gentle swirls. Sunbeams filter down in calm ribbons, glowing with a muted brilliance. Shadows blur at the edges. Highlights fade slowly, giving the landscape a dreamlike stillness. And then comes sunset, a scene shaped by a star whose temperature determines its palette. A planet orbiting a red dwarf star might experience evenings bathed in warm, rose-coloured light, as though the horizon were dipped in glowing embers. The sky could shift from soft pink to smoky orange, settling into dusky reds that linger for hours. On a world orbiting a blue-white star, the sunset might shimmer through shades of turquoise, silver or icy gold. The atmosphere becomes a canvas for cosmic light, painting slow gradients across the horizon. The clouds too reflect the unfamiliar chemistry of these worlds. Some may be laced with metallic particles, shimmering like brushed copper. Others could form thick pastel layers that drift lazily across the sky, tinted by the minerals that make up their droplets. On certain worlds rich in sodium or silicates, the clouds might glow softly at night, catching and scattering starlight in delicate halos, a quiet luminescence like moonlight woven through mist. As these skies shift, the surface below transforms with them. Water, if present, might reflect alien colours, painting calm waves in hues of jade or saffron. Rocky plains may take on cool blue shadows or warm apricot tones. Forests, if they exist, could be tinted in unexpected shades, shaped by photosynthetic pigments adapted to their star's unique spectrum. In this gentle imagined moment, feel yourself lying beneath such a sky. The air is warm and dense, carrying the faintest mineral scent. Light filters down in slow, steady breaths. You watch the horizon, letting time soften around you. The colours deepen, then fade, then return in new combinations you've never seen before. There is no urgency here, only light unfolding, only the sky practicing its slow cosmic art. Under these unknown suns, every world tells its own quiet story, painted not with words but with colours drifting across the sky. Imagine a world where the concept of a shoreline simply doesn't exist. A super-Earth enveloped entirely by ocean. A blue sphere without continents, without islands, without even a single exposed ridge of rock breaking the surface. Just water, stretching in every direction, meeting the horizon in a seamless curve. On Earth, oceans are framed by land, held in place by continents that rise like protective walls. But here, on a true water world, the ocean is the planet. It is the surface. It is the landscape. As you breathe slowly, picture the stillness of such a place. The ocean is deep, far deeper than anything known on Earth. Even our Mariana Trench, with its crushing pressures, would feel shallow compared to the vast layered waters of a super-Earth ocean. Gravity, stronger than Earth's, pulls the water downward with calm persistence, creating basins so immense and so deep that sunlight cannot reach their lower regions. The surface may shimmer brightly under an alien sun, but below, darkness stretches for tens or even hundreds of kilometers. The waves here move differently. Stronger gravity smooths them, flattening their crests, slowing their motion. Instead of sharp, quick waves, these oceans breathe in long, rolling motions. Wide swells that take minutes, not seconds, to rise and fall. The sound of such waves would be deeper, lower, carrying a resonant hum rather than a crisp splash. If you floated on this ocean, the movement beneath you would feel like drifting on the breath of a sleeping giant. The sky above reflects off the water in colours shaped by the planet's thick atmosphere. Greens, purples, muted oranges, or deep blues ripple across the surface in slow patterns. Sunlight filters through the haze, turning the ocean into a luminous sheet of soft, diffused brightness. Even during the day, the horizon has a gentle blur, the line between sea and sky softened by moisture, vapour, and scattered light. Without land to interrupt them, storms may circle the planet endlessly, guided by global wind currents that never meet a mountain or a continent to break their path. Yet even storms here move differently. In the dense atmosphere of a super-Earth, clouds gather slowly, forming vast layered structures. Rain falls in thick, heavy droplets that descend with deliberate weight. Thunder rolls softly, its sounds stretched and muted by the thick air. The world feels wrapped in a continuous hydrological rhythm: evaporation, condensation, rainfall, repeating in a calm planetary heartbeat, and beneath the surface life might find refuge. On Earth, marine ecosystems often cling to coastlines, shallow reefs and patches of sunlight, but on a super-Earth ocean, life could concentrate around hydrothermal vents, deep volcanic fissures where heat rises from the planet's interior. Imagine entire ecosystems illuminated not by sunlight, but by faint bioluminescent glows, drifting like constellations in the dark. Slow-moving creatures with wide, flexible bodies navigating the depths, microbial mats shimmering with chemical energy, life forming not around land, but around warmth and minerals. At the surface, floating organisms, delicate, buoyant, translucent, could drift with the wide, slow currents. They may glow softly at night, creating ribbons of blue or green light across the waves, a planet-wide aurora carried by tides instead of wind. As you picture this ocean without shorelines, feel the softness of its rhythm settle into your breath. No boundaries, no sharp edges, only the slow expansion and contraction of a global sea, a world where water is everything and everything is water. On Earth, mountains rise in sharp defiance, reaching for the sky with jagged ambition. But on a super-Earth, where gravity holds the land more firmly, mountains grow differently. They do not spike upward. They do not pierce the sky in sudden thrusts of stone. Instead, they stretch outward, vast, wide, and ancient, their silhouettes softened by the persistent pull of the world beneath them. Here, mountains touch the edge of night not by height, but by breadth, by presence, by the way they absorb and release light in long, patient waves. Imagine standing at the foot of such a formation. The ground slopes gently upward for kilometres, a slow rise that feels almost like walking into a dream. There is no abrupt cliff, no dizzying ascent, only a gradual unfolding of land, as though the planet were lifting you toward its horizon with careful, steady hands. The air thickens slightly as you climb, making every breath a little warmer, every inhalation a little richer. And as you ascend, the sky deepens in colour, shifting in subtle gradients shaped by the planet's dense atmosphere. Light behaves differently on such slopes. During the long approaches of evening, the sun falls slowly, scattering through layers of haze that tint the landscape in muted hues: dusty rose, cool lavender, soft amber. Shadows stretch wider rather than longer because the land itself spreads so far. From the mountainside, the world seems peaceful and enormous, a place where distances unfold with calm inevitability. It is not a landscape that challenges you, but one that invites you inward. The surface of these mountains reveals their history. Compressed by stronger gravity, rocks form dense, stable patterns. Smooth mineral plates overlapped like the pages of a stone book. Rivers carve gentle channels instead of deep ravines. Erosion shapes sweeping terraces rather than jagged ridges. And because the mountains rise slowly, weather systems drift across them in languid rhythms, spreading moisture and wind in broad blankets rather than turbulent spirals. On some super-Earths, volcanic activity might carve these ranges from within, creating wide calderas where molten rock glows with quiet intensity. Lava on such worlds flows more slowly, its weight pressing it close to the ground, its heat radiating with steady warmth rather than explosive bursts. A mountain here might glow subtly at night, its fissures releasing soft plumes of steam into the heavy air. The sight would feel less dramatic than Earth's volcanoes, more like watching the quiet breathing of a planet. If life exists in these highlands, it would adapt to the unique balance of light, gravity and pressure. Plants might cling low to the surface, their roots anchored into dense soil. Their colours could differ from those on Earth, shaped by the spectrum of an alien sun. Some might glow faintly at dusk, absorbing the last traces of daylight and releasing them slowly into the thickened air. Creatures, if present, would move with careful strength, each step measured, each gesture efficient. As you imagine yourself on such a mountainside, breathe in gently. Feel the weight of the world beneath your feet. A grounding sensation, steady and reassuring. The horizon curves softly around you. The sky above deepens as stars begin to appear, shimmering through layers of haze like distant lanterns floating in slow motion. On this super-Earth, mountains do not challenge the heavens, they cradle them. They hold the night close, letting darkness settle in calm, embracing waves. Standing there, you feel small, not diminished, but peacefully humbled, a quiet guest beneath a sky shaped by gravity and time. As we drift deeper into these imagined worlds, a quiet and provocative question emerges. What if some planets are not merely habitable, but better suited for life than Earth itself? The idea of superhabitability suggests that somewhere in the galaxy there may be worlds more accommodating, more stable and more nurturing than our blue home. Not better in an emotional sense, but in the cool, patient language of planetary science. A world whose conditions tilt gently toward life, like a cradle carved by the cosmos. A super-Earth, with its greater mass, often holds onto its atmosphere more firmly. This means fewer extremes, fewer violent temperature swings, fewer wild climate cycles, fewer sudden changes in air composition. Imagine a world where the storms roll softly, guided by dense, stable layers of air, where rainfall comes in warm, heavy drops that nourish broad plains and vast shallow seas, where the sky cushions sunlight into a gentle glow rather than a harsh blaze. Such stability could grant life a long, unbroken stretch of time in which to grow and evolve. On Earth, mass extinctions have reset the clock repeatedly. But on a more stable world, without intense temperature fluctuations or dramatic shifts in climate, life might expand outward in smooth, continuous arcs. Forests could stretch unbroken for thousands of kilometers. Oceans might remain calm for millions of years at a time. Evolution could proceed not in frantic leaps, but in serene spirals. Imagine the vegetation of such a planet. With richer air and abundant warmth, plants might grow taller, broader, or stranger than anything we know. Leaves adapted to a slightly dimmer star might deepen in colour, twilight blues, deep reds, or soft purples, capturing every gentle photon with patient efficiency. Forest canopies might glow softly in the filtered light, creating landscapes that feel like living dusk. The air would be thick with oxygen and moisture, warm enough to breathe deeply, cool enough to walk comfortably. Creatures living there might be strong and graceful, shaped by steady gravity and stable climates. Some could move slowly, conserving energy in a world that doesn't rush. Others might glide between dense layers of atmosphere, buoyed by air that cradles their bodies. Over time, intelligence might emerge in a form that reflects the planet's calm, contemplative rather than hurried, attuned to the quiet rhythms of a world that rarely surprises. Even the oceans of a superhabitable world could offer deeper stability. Warm currents might circulate gently, creating vast safe regions for marine life to flourish. Bioluminescent creatures could drift in slow, swirling patterns, illuminating the water with ribbons of colour at night. Coral-like structures might spread across enormous undersea plains, forming ecosystems of breathtaking richness. Yet, for all its potential perfection, the idea of superhabitability also reminds us of something tender. Earth may not be the universe's optimal cradle, but it is ours. We evolved within its imperfect fluctuations, its storms and seasons, its droughts and floods, its unpredictable nature. Our bodies carry the memory of its rhythms. Our minds, too, are shaped by its changing skies. Still, it is soothing to imagine a world where life finds an even gentler home, a world where nature moves with calm consistency, where evolution drifts without interruption, where ecosystems weave together in quiet, intricate harmony. As you breathe slowly, picture such a world as a soft possibility, not better than Earth in spirit, but perhaps more patient, more steady, more welcoming to life's delicate beginnings. A cradle carved not by chance, but by the gentle mathematics of balance. Every star, no matter how bright or dim, carries around it a silent ring, an invisible band where temperatures fall into a gentle balance that allows liquid water to exist. Scientists call it the Goldilocks zone, a place not too hot, not too cold, but quietly poised between extremes. In this thin orbital shell, a world has the chance to cradle oceans, nurture atmospheres, and support the slow unfolding of life. It is a humble concept, but a profound one, reminding us that habitability is not born from perfection, but from balance. Imagine the star at the centre of such a zone. If it is a small, cool red dwarf, the Goldilocks ring lies close in, where a planet might orbit so tightly that its year lasts only a handful of Earth days. On the other hand, if the star is larger and hotter than our Sun, the zone drifts farther out, stretched wide like a long, slow path around a bright fire. But regardless of the star's nature, this quiet ring offers something precious. Temperatures that remain steady enough for water to stay liquid, the ingredient that makes chemistry slow down, connect, and eventually bloom into life. Picture a super-Earth drifting gently through this band. Its orbit is stable, its path smooth, its seasons shaped by the careful angle at which it meets its star's light. Day by day, or year by year, depending on the orbit, sunlight bathes its surface in a warmth that neither burns nor freezes. The atmosphere absorbs and releases heat in a soft rhythm, like a breath that never rushes. Even nights here feel patient, held in the memory of the day's warmth. Life, if it arises, is given time to adjust, to evolve, to expand. The idea of a Goldilocks zone often sounds like a strict requirement, a narrow window where everything must be perfect. But in truth, it is more forgiving than that. A thick atmosphere can warm a planet outside the zone, just as a thin atmosphere can cool one inside it. Oceans, land masses, clouds, they all collaborate to regulate temperature. The Goldilocks zone is not a guarantee, but an invitation. It says, here, conditions might be right. Here, life could begin its long, quiet work. On a super-Earth within this zone, the experience of sunlight would feel different from ours. The sky might glow in muted hues, shaped by gases unknown on Earth. Sunrises could stretch longer, as thick air refracts the star's light into slow gradients. Even the weight of gravity contributes to the world's warmth, holding air close, letting heat circulate in calm layers. Everything on such a planet exists in a patient equilibrium. As stars age, their Goldilocks zones shift, moving slowly outward as the star brightens over billions of years. Some planets drift out of habitability, others drift into it. A world may spend eons in silence before entering the right range, like a seedling waiting for its first gentle rain. The universe is not hurried in its timing. It lets worlds wander into possibility on their own schedules. As you breathe softly, imagine this ring around every star. A cosmic cradle, quiet and unassuming, waiting for the right world to drift through it. A world where water could flow, where life could take a fragile breath, where an atmosphere could settle into its rhythm. The Goldilocks zone is not rare. The galaxy is rich with these warm circles of potential, each one another whisper of hope. Tonight we continue wandering through them, stepping from one calm orbit to the next, letting each possibility open like a soft petal in the dark. Imagine a world orbiting a red dwarf star, one of the most common stars in our galaxy, smaller, cooler, and dimmer than our sun. A red dwarf glows not with bright white light, but with a deep, ember-like warmth. Its glow is soft, steady, and slow, pulsing with the colour of a lingering sunset. On a planet circling such a star, daylight never feels harsh. It arrives as a gentle wash of reddish gold light, spread thinly across the sky, giving every hour the quiet ambience of dusk. As you breathe slowly, imagine standing on the surface of this super-Earth. The sunlight feels different here. It doesn't glare, it doesn't burn. Instead, it drapes across the landscape like a warm cloth, casting long, soft shadows that stretch out patiently behind rocks, plants, or any life that might exist. Even at midday, the sky might retain a dusky tint, peach, rust, or muted crimson, shaped by both the star's colour and the planet's thick, scattering atmosphere. Days on such a world unfold calmly. Because the star shines with a lower intensity, the habitable zone lies close in, a tight orbit where a year might last only a few Earth days or weeks. From the surface, the star appears larger in the sky, glowing like an enormous red lantern hanging just above the horizon. Its light is gentle but persistent, a constant ember that never fully fades. The warmth it provides is steady, yet the spectral quality of the light shifts how the world below evolves. Plants, if they exist, might absorb the red-rich light using different pigments than Earth greens. Imagine broad fields of deep violet vegetation, or soft black leaves that shimmer subtly in the ruddy glow. Photosynthesis here would follow a slower rhythm, guided by wavelengths better suited to infrared and red light. Forests would look like dreamlike sculptures cast in warm, shadowed tones. Air on such a world might feel slightly warmer than expected, even far from the equator. Red dwarfs emit a great deal of infrared radiation, heat that thick atmospheres can capture and distribute evenly. Nights too might stay mild, especially if the planet is tidally locked, with one side forever facing the star. On such a world, the Twilight Zone, the boundary between day and night, would stretch around the globe, offering an endless band of soft lighting. Imagine living there, in a horizon of eternal evening, where the warmth of the star glows from one side while the cool, quiet dark draws in from the other. Life could find this gentle balance appealing. Too much light can be harsh, too little can be limiting. But here, beneath the glow of a red dwarf, existence might settle into a calm, adaptable range. Creatures could evolve eyes fine-tuned to low-level illumination, able to see well in dim conditions. Plants may spread slowly across plains, their colours deep and rich. Even the oceans might reflect the starlight differently, turning warm copper or muted maroon as waves break softly beneath the star. Of course, red dwarfs can be active, flaring, pulsing, releasing sudden bursts of energy. But over time, especially for older stars, these outbursts become less frequent, allowing their worlds long periods of peaceful stability. A mature red dwarf can burn steadily for trillions of years, far longer than our sun, giving life immense stretches of time to take hold, adapt, and flourish. As you rest in this imagined twilight, let the scene settle around you, a sky lit by a forever sunset, a world warmed by ember light, an atmosphere painted in soft tones that never quite give way to full daylight. Here, time feels elongated, softened, unhurried, a place where life, if it exists, moves with patience and grace. A realm lit not by brilliance, but by warmth, not by sharp sunlight, but by a calm, glowing dusk that never truly ends. Some worlds orbit their stars so closely and so steadily that they become tidally locked, forever turning the same face toward their sun. On these planets, one hemisphere lives in perpetual daylight, while the other rests in eternal night. There is no sunrise, no sunset, no spinning cycle of light and shadow. Instead, the sky holds its position, fixed like a painting stretched across time. And between the blazing day and the frozen dark lies a thin, gentle band called the Terminator Line, a place of perpetual twilight where temperatures settle into a quiet balance. Imagine yourself standing in that twilight zone. Ahead of you, the star hangs motionless in the sky, glowing with a soft, unwavering presence. Behind you, darkness stretches infinitely, a cool ocean of shadow untouched by light. The air here is calm, shaped by the steady tug of war between heat and cold. Gentle winds drift from the dayside toward the night, carrying warmth across the boundary. They feel like slow breaths, warm on one side of your skin, cool on the other, blending the extremes into a tranquil middle ground. On the day side, the light is constant. Plants, if they exist, might grow in continuous cycles without needing rest, spreading broad leaves adapted to steady illumination. The soil would feel warm underfoot, heated by never-ending starlight. Oceans or lakes on this side might shimmer endlessly, their surfaces glowing with reflections that never change angle. Clouds gather and disperse in rhythmic, predictable motions, driven not by rotation but by the simple physics of hot air rising and cool air sinking. On the night side, everything is frozen in darkness, but it is not a lifeless silence. Ice structures could stretch upward in vast crystalline plains. The stars, unbroken by daylight, would shine with razor clarity, scattered across an eternal midnight sky. If the atmosphere is thick enough, some faint glow from the dayside might scatter across the horizon, creating a soft halo of refracted light. Volcanic vents could break the darkness with quiet red glimmers, offering warmth in pockets where life might cling. But the most hospitable region, the place where life has the highest chance to flourish, is the Terminator Line itself. Here, temperatures hover in a stable middle range. Light is dim but constant, like a perpetual early evening. Plants could evolve pigments tuned to the low glow, absorbing what light they can. Creatures might adapt large eyes or reflective surfaces to navigate the perpetual dusk. Rivers may form from melting ice on the night side, flowing slowly toward the warm, sunlit hemisphere. This twilight ring becomes a ribbon of possibility, wrapped around the planet like a soft glowing band of life. Time on a tidally locked world feels different too. Without a cycle of sunrise and sunset, life might regulate itself according to tides, temperature changes, or the subtle shifting of winds. Sleep patterns could align with internal rhythms rather than external cues. Existence would be guided by gradients instead of clocks. Warmer here, cooler there, dimmer here, darker there, softer here, brighter there. Everything flows in gentle transitions rather than sharp contrasts. As you breathe softly, imagine the calm of this twilight world. One step in either direction leads you toward extremes, searing brightness or icy shadow. But here, in this balanced band, you feel as though the planet is holding you carefully between opposites. The light never overwhelms, the darkness never isolates, the temperature drifts around you like a steady tide. A world divided into day and night, yet offering peace in the place where they meet. A world where twilight is home. A world that teaches us quietly that harmony often exists not in sameness, but in the gentle meeting of contrasts. Every planet has its own voice, shaped by its air, its mountains, and the slow turning of its world. On a super-Earth, where gravity settles the atmosphere into thicker layers and landscapes stretch wide beneath deeper skies, the wind becomes a language, not sharp, not hurried, but low and resonant, moving through valleys in long melodic currents. These winds do not rush, they drift, they hum, they breathe across the land like a soft instrument tuned by the physics of an alien world. Imagine standing at the mouth of a vast valley on such a planet. The ground spreads out before you in broad, gentle slopes, shaped by gravity's steady weight. The air is dense and warm, carrying the faint scent of minerals suspended in its layers. As you inhale, the atmosphere feels slightly heavier than Earth's, pressing lightly against your skin. High above, the sky glows with muted colour, perhaps a soft amber, perhaps a slate blue tinted by exotic gases, and then, from far away you hear it, the wind. It doesn't whistle the way Earth's wind does, it sings, a low vibration created by air moving through narrow passes carved slowly over millions of years. Because the atmosphere is thicker, sound carries differently. Notes deepen, edges soften. A gust of air flowing past a rocky outcrop might produce a gentle flute-like tone, while broader currents generate warm, resonant hums that echo throughout the valley. The entire landscape becomes an instrument, played not by intention, but by nature's quiet persistence. These winds move with purpose. Warm air from sunlit plains rises and sinks with calm rhythm, creating slow, steady circulations. They do not rush with sudden force, but glide in layered sheets, each one moving at its own pace. Imagine watching a cluster of alien plants, low and wide to withstand the gravity, bending gently to the wind's movement. Their leaves, perhaps deep red or midnight blue, tuned to absorb the dim spectrum of a cooler star, flutter not sharply but with a smooth wave-like motion. It feels less like weather and more like breathing. In the deeper parts of the valley, the wind becomes cooler, sliding against rock faces that have been smoothed by eons of pressure. Here the soundscape changes. The hum becomes quieter, the tones more delicate. Tiny particles in the air, metallic dust or mineral grains, shimmer briefly as they catch the filtered light, drifting like soft sparks carried on invisible currents. If water flows through this valley, it responds differently too. Thick air presses gently on its surface, smoothing ripples, slowing waves. A creek might move with a muted sound, the babbling softened into something closer to a purr. When the wind brushes against it, it creates patterns of overlapping circles spreading slowly as though painted on glass. Even water here seems to move more thoughtfully. Life on such a world, if it exists, would likely tune itself to these winds. Sensitive hairs, frilled membranes, or wide sensory surfaces might evolve to interpret subtle vibrations in the air. Some creatures could communicate through low-frequency tones, letting the valley carry their voices farther than sight can reach. Others might glide short distances, buoyed not by wings designed for lift, but by the dense atmosphere flowing beneath them like a supportive cushion. As you let your breath slow, imagine the peace of listening to this valley wind, a sound with weight, a sound with warmth, a sound that carries across the land like an ancient lullaby. It is neither fierce nor restless, it simply exists, shaped by the planet's deeper gravity and its rich, embracing sky. A gentle reminder that even on worlds far from home, nature finds ways to create music. Sometimes, it just sings in lower, calmer tones, Long before we could see distant worlds directly, we learned to listen for them. Not with our ears, but with instruments sensitive enough to detect the faintest changes in starlight. Tiny dimmings, gentle tugs, subtle shifts in motion. Out there in the quiet dark, planets reveal themselves not through brightness, but through influence. They whisper their presence by how they make their stars move, breathe and flicker. In this way, discovery becomes an act of listening rather than looking, a contemplative science shaped by patience and delicate attention. Imagine a distant star as a lantern floating in black water. A planet orbiting invisibly pulls on it in rhythmic cycles. The star doesn't stay perfectly still. It wobbles ever so slightly, drifting toward us and away again. With every tug, starlight stretches or compresses, shifting its colour by amounts too small for human eyes to detect. But our instruments can feel it. The radial velocity method, as scientists call it, is a way of sensing the heartbeat of a planetary system, the subtle sway of a star responding to the gravity of its companions. Then there is the transit method, a quieter, more visual whisper. When a planet crosses its star's face, the star dims by a tiny fraction. Not enough for us to see directly, but enough for sensitive telescopes to record. These dips in brightness repeat with perfect regularity, soft, predictable pulses that reveal the planet's size, its orbit, and even hints of its atmosphere. Imagine watching a star's light curve, a gentle wave that dips ever so slightly every time the world passes in front of it, a pulse, a breath, a rhythm. Most of the super-Earths we know today were discovered this way, not by sight, but by motion and shadow. Instruments like Kepler and TESS watch thousands of stars at once, waiting for a dimming so slight it might be mistaken for noise. But patterns emerge, repetition forms, a signal rises from the quiet, and suddenly a new world enters our awareness, a planet we will never touch, never see with naked eyes, yet can describe with remarkable clarity. These discoveries feel intimate in a strange way. To find a planet by its gravitational pull is to sense its presence the way you might notice someone stepping softly onto a wooden floorboard, not by sight, but by the slight shift beneath your feet. To detect a transit is to watch a shadow pass gently across a lantern, revealing the outline of something invisible. It is astronomy built not on spectacle, but on subtlety, and there is poetry in the precision. A world the size of Earth can dim its star by less than 1 part in 10,000, like a firefly briefly passing in front of a lighthouse beam. Yet that tiny change carries enormous meaning. It tells us the world exists. It tells us how long its year lasts. It tells us its size, and sometimes even the mixture of gases that wrap around it. Imagine lying beneath your blanket, breathing slowly, and knowing that somewhere, light from a star hundreds of trillions of kilometers away has dipped by a fraction, because a world crossed in front of it at just the right moment, a planet that may have oceans, a planet that may have clouds, a planet that, in its quiet orbit, affected the light we receive here on Earth. We discover worlds not by travelling, but by noticing, by attending to the faintest changes in the universe's glow, by listening for wobbles in the dark. When we look for life on distant worlds, we cannot search for cities or forests or oceans directly. The light is too faint, the distance is too vast. Instead, we study the thin, delicate film that surrounds a planet, its atmosphere. A world's air becomes its signature, revealing hints of chemistry, temperature, and even the possibility of breath. In the soft glow of starlight passing through an atmosphere, we can find whispers of what might live beneath it. Imagine a planet crossing in front of its star. As it moves across that glowing face, a small fraction of the star's light filters through the planet's atmospheric shell. Molecules in the air absorb certain colours: oxygen, methane, water vapour, carbon dioxide, and many others. When this filtered light reaches our telescopes, it carries a subtle imprint, a quiet fingerprint etched by the gases that shape the planet's sky. This method, called transmission spectroscopy, lets us read a world's atmosphere the way we might read the grain of wood or the bands of a seashell, gently, patiently, with care. Oxygen, for example, is a powerful clue. On Earth, it exists in large amounts only because life continually replenishes it. Left alone, oxygen reacts quickly with rocks and minerals. Without living things to produce it, the air would turn still and silent. So if we detect strong, stable oxygen on a super-Earth far from home, it raises a delicate question. Is something there breathing? Methane is another storyteller. In small amounts, it can arise from geological processes. But in large, steady quantities, methane and oxygen together form a disequilibrium, a tension that hints at biological cycles. Water vapour signals the possibility of oceans or lakes. Carbon dioxide reveals greenhouse effects and surface temperatures. Even the thickness of a planet's air can be inferred from how deeply starlight dips during a transit. As you breathe softly now, imagine inhaling the air of an alien world. Not literally, of course, but in your mind. A warm, dense atmosphere carrying minerals and scents unlike anything on Earth. The light filtering through it would tint the sky in strange colours: soft peach, violet blue, pale gold, or deep green, depending on the gases suspended there. If life's subtle chemistry were present, you might catch glimpses of it in the way light changes, in the way clouds form, in the patterns of heat rising from the surface. On some super-Earths, the atmosphere might be far thicker than Earth's, a warm, enveloping blanket that traps heat gently, creating climates of remarkable stability. On others, the air could be thin and razor-sharp, letting starlight cut cleanly through to the surface. Each atmosphere is a story waiting to be read, a poem encoded in gases, pressure, and light. Even without life, atmospheres offer beauty. Volcanic planets may fill their skies with shimmering minerals. Ocean worlds might send plumes of mist into the air, scattering starlight into shimmering halos. Tidally locked planets could carry heat from the lit side to the dark side in slow, continuous currents, creating breathtaking patterns in temperature and wind. We study these atmospheres not only for clues to life, but to understand how worlds breathe, evolve, and balance themselves. Yet the thought of life lingers, a quiet, hopeful hum beneath the science. If we one day detect a blend of gases that cannot be explained by geology alone, we might be witnessing the collective breath of an ecosystem. Forests exhaling, oceans releasing, tiny organisms drifting through their planet's air. A whole world inhaling and exhaling in slow rhythm. And all of it detectable from unimaginable distances, carried to us on the soft wings of starlight. On Earth, we take the colour of the sky for granted, a soft blue during the day, fading into golds and reds at sunset, then into the deep velvet of night. But sky colour is not universal. It is not a cosmic constant. It is a delicate interplay between starlight, atmosphere, and the unique chemistry of each world. On alien planets, the sky might glow in shades that feel dreamlike, impossible, or quietly breathtaking. Sapphire, amber, hematite blue, smoky violet, or colours we don't even have names for yet. Imagine waking beneath a super-Earth sky tinted by thick layers of mineral-rich air. The sun, perhaps a cool red dwarf or maybe a bright white star, sends its light cascading through gases that scatter each wavelength differently. Instead of the familiar blue, you might see a shimmering sapphire sky, deep and rich, almost like looking into an endless ocean tipped upside down. Or perhaps the atmosphere is filled with fine particles from volcanic vents, painting the sky in warm amber hues that glow softly from dawn until dusk. Then there is hematite blue, a colour that might arise from iron-rich dust suspended in the air. It's a darker, cooler shade of blue, almost metallic, shifting gently as the star's light changes. Such a sky would feel heavy, yet comforting, like lying beneath a twilight dome shaped by mineral breath. As you breathe slowly, imagine watching these colours change throughout the day. On Earth, sunsets are brief, a few minutes of rapid transition. But on a super-Earth with a denser atmosphere, light lingers. Colours unfold gradually, in long, slow waves. A sunrise might take an hour to complete, with the sky drifting from deep indigo to soft rose to muted gold. A sunset could stretch even longer, its hues dissolving like watercolour into the horizon. Clouds contribute their own artistry. In a heavier atmosphere, clouds form thicker layers, casting wide shadows and glowing brilliantly when light catches their edges. Some clouds might be enriched with silicates or exotic ices, giving them subtle shimmer, faint metallic gleams like brushed silver or pale copper. On certain worlds, clouds could rise into massive tiered structures, drifting so slowly that their movement resembles the steady breathing of a sleeping creature. The landscape below responds to these colours, reflecting and refracting them in gentle ways. Oceans might take on the tone of the sky, becoming deep sapphire or warm amber. Rocky surfaces could absorb the mineral tints from the air, creating landscapes painted in unexpected palettes. Lavender dunes, teal shadows, orange-tinged cliffs. Even plants, if they exist, might evolve pigments tuned to the unique spectrum of light, adding streaks of red, black, purple or iridescent green to the terrain. Some worlds might host skies with multiple colours layered at once. Imagine standing on a ridge as a pale emerald glow hovers near the horizon, while the upper sky fades into a deep violet, the result of complex scattering in the thick atmosphere. Or picture a world bathed in permanent twilight, where the star never rises fully and the sky stays tinted in soft metallic hues that drift between silver and blue. And then there are the unknown colours, hues our eyes are not built to perceive. On distant worlds, under alien stars, light might scatter in wavelengths outside our visual spectrum. Creatures native to those worlds might see skies we cannot imagine, painted in spectral poetry our minds cannot access. For them, the sky might feel alive with colours that shift and hum, weaving patterns that guide their movements or signal the changing seasons. As you let your breath slow, imagine the comfort of lying beneath one of these alien skies, a dome of unfamiliar colour stretching softly above you, echoing with the quiet beauty of a world shaped by different physics, different chemistry, different light. A reminder that the universe paints with a far wider palette than the one we know. Not all worlds shine because of their suns. Some glow from within, warmed by restless interiors, shaped by ancient pressure, and scarred by slow, powerful eruptions that never fully cease. These are supervolcano worlds, planets where geological activity moves not in sudden violence, but in patient, continuous breaths. Molten rock flows through subterranean arteries, heat rises gently through fissures, and the surface glows with quiet ember-like light, as if the planet carries its own soft heartbeat beneath the crust. Imagine arriving on such a world at dusk. The sky cools into deep violet, shaped by a dense atmosphere rich with mineral dust. As the last light of the star fades, something remarkable occurs. The ground beneath your feet begins to shimmer, not in flames, not in explosions, but in faint red lines glowing softly from cracks and vents scattered across the landscape. These glowing seams pulse with geothermal warmth, stretching like delicate veins across dark plains. They do not roar, they do not threaten. They simply illuminate the land in warm rhythmic tones, like the quiet firelight of a sleeping giant. On Earth, Volcanoes are dramatic, eruptions, ash clouds, rivers of lava racing downhill. But on a super-Earth with stronger gravity, molten rock behaves differently. It flows slowly, held close to the surface by the planet's weight. Lava doesn't jet upward with force. Instead, it creeps outward in broad, glowing sheets that cool gradually, forming smooth, dark surfaces rich with minerals. These expansive flows reflect the light from the sky and from the cracks beneath, creating landscapes that gleam gently even at night. As you breathe deeply, imagine walking across one of these plains. The warmth rising from the ground is steady, comforting, like standing near a warm stone at sunset. The air is thick, holding the heat close, dispersing it slowly. You notice how sound behaves differently here too. Thick atmosphere and molten surfaces absorb noise, muffling footsteps, softening even distant rumbles. The world feels muted, wrapped in a natural hush. Geysers might erupt in low rhythmic bursts, sending plumes of steam drifting lazily into the air. These plumes catch the faint red glow from below, turning into soft pink clouds that move with dreamlike slowness. Minerals carried upward by the steam settle as shimmering dust across rock formations, leaving iridescent patterns that sparkle gently in the ambient light. Life, if it exists, could thrive in the warmth of these geothermal networks. On Earth, deep-sea vents teem with creatures who rely not on sunlight, but on chemical energy rising from the planet's interior. On a supervolcano world, similar ecosystems might stretch across entire continents. Imagine fields of microbial mats glowing faintly, feeding on minerals and heat. Picture plants with thick, heat-resistant tissues clinging near vents, absorbing warmth instead of sunlight. Picture gentle organisms navigating the warm, mineral-rich pools that dot the landscape, their shapes shifting in the soft glow. Even from orbit, such a planet would appear extraordinary. Instead of a uniform dark side, it would show glowing patches, subtle embers beneath long night, revealing its internal warmth, a world that shines without needing its star. As you rest deeper into your pillow, imagine standing on this glowing surface, the warmth beneath your feet rising in waves, the sky above tinted by volcanic minerals, the air carrying a soft, metallic scent. Here, the planet itself is a source of light, not bright, not harsh, but soothing and ancient, a quiet fire that has been burning for billions of years, a world illuminated from within. Not all super-Earths glow with fire. Some sleep beneath blankets of ice so thick and ancient that sunlight never reaches the oceans below. These are frozen giants, worlds where cold shapes the landscape. Silence settles like snowfall, and time slows into something vast and patient. On such planets, the surface can feel like an abandoned dream, pale, untouched, stretching endlessly toward a horizon softened by frost. Imagine standing on the crust of a frozen super-Earth. Beneath your feet lies a shell of ice that may be tens or even hundreds of kilometers thick, pressed together by gravity stronger than Earth's. The air is cold, but still, too still perhaps. Winds move sluggishly in the dense atmosphere, as if burdened by their own weight. They carry faint crystalline scents, the aromas of frozen minerals and drifting particles of frost. When you exhale, your breath disperses slowly, hanging in the air before fading into the quiet. Above you the sky glows with subdued colours. Ice worlds orbiting red dwarves might have a soft copper tint to their skies. Those around hotter stars may shimmer in pale blue or silver. Yet everything feels muted, as though the planet is whispering rather than speaking. Thick atmosphere diffuses the light, spreading it gently across the icy plains. Shadows soften, edges blur, time stretches. Deep below this silent crust lies warmth, not from the sun but from the planet's core. gravity and radioactive elements generate heat that cannot escape easily through the thick ice. Instead, it collects in subsurface oceans, vast and hidden, swirling slowly in the dark. These oceans may be deeper than any body of water on Earth, heated by hydrothermal vents that glow softly like embers drifting across the sea floor. Here, the planet's warmth meets its cold outer shell, creating a boundary rich with strange potential. As you breathe rhythmically, imagine floating in the water beneath this ice. It is dark, but not empty. The pressure is immense, but strangely comforting. The water moves in slow, deliberate currents, carrying minerals, heat, and possibly life. On Earth, hydrothermal vents support ecosystems teeming with creatures who rely on chemistry rather than sunlight. On a frozen super-Earth, similar organisms might drift through this black water, glowing bacteria, ribbon-like swimmers, colonies forming delicate webs anchored to rocky outcrops. Their bioluminescence might shimmer softly, a galaxy of tiny lights swirling in the darkness. Occasionally, warmth below fractures the ice above. Cracks spread slowly, releasing plumes of vapour that shoot upward into the atmosphere. These cryo-volcanic eruptions are not explosions of fire, but geysers of water vapour, ammonia, or methane ice. The plumes rise, freeze, and fall as glittering snow, painting the world in shining layers that reflect alien starlight. Standing on the surface, you might see distant eruptions as pale, ghost-like columns rising gently toward the sky. The silence on such a world is profound. No rustle of leaves, no rush of waves, no call of animals, only the soft whisper of wind sliding across ice, and the distant, almost imperceptible groaning of glaciers shifting under their own weight. It is a silence that doesn't feel empty. It feels contemplative, like the pause between slow breaths. And yet, beneath that quiet, the planet is alive with motion. Oceans churn, heat pulses upward, ice expands and contracts in long cycles, minerals drift through the dark. Even in the coldest corners of the galaxy, worlds like these hold warmth within. As you settle deeper into your pillow, imagine the peacefulness of standing on such a world, wrapped in cold, surrounded by silence, comforted by the knowledge that life does not always need sunlight. Sometimes, warmth arrives from within, carried patiently through the long night, a frozen giant sleeping softly beneath a shield of ice, a world that remembers its own heat. Not all volcanic worlds erupt in bursts of chaos. Some release their heat in slow, measured exhalations, long stretches of molten rock drifting across the landscape like glowing rivers of sleep. On certain super-Earths, the combination of strong gravity, thick crusts, and persistent internal warmth creates magma plains, vast expanses where molten rock flows in steady, unhurried currents. These plains do not roar, they do not explode, they move like time itself, patient, heavy, inevitable. Imagine stepping near the edge of such a plain. You feel the warmth before you see the light. It rises through the soles of your feet as a deep, lingering radiance, like standing near a slowly cooling forge. Then, as you look outward, the landscape opens into a wide sheet of shimmering red-orange glow. The lava here moves differently than on Earth. Stronger gravity presses it close to the surface, preventing dramatic fountains or splashes. Instead, it spreads out in calm, glowing sheets, a quiet ocean of stone in its liquid form. The surface looks almost alive. Patterns of dark crust form, crack, and heal again in slow cycles. Long fractures create glowing lines that pulse softly, illuminated from below. Every motion feels deliberate, shaped by gravity's steady hand. There are no sharp edges, no sudden bursts, only smooth transitions, as if the molten rock is practicing a slow, meditative dance. Above the plains, the air shimmers with heat, bending distant shapes and softening the horizon. The sky might glow in muted tones, copper, grey or deep amber, depending on the mineral-rich gases released by the molten surface. Ash doesn't rise in violent plumes here. Instead, fine particles drift upward in thin, ghost-like veils carried by gentle thermal currents. When they fall again, they dust the solid ground in soft mineral layers that glint faintly under alien starlight. If you breathe deeply in this imagined landscape, the air feels warm and thick, carrying a slight metallic scent. Not harsh, but earthy, a reminder that the planet itself is still forming, still shifting, still releasing the memory of its creation. You might hear faint pops or cracks in the cooling crust, but even these sounds feel subdued by the atmosphere's density. Everything here seems tuned to a lower, calmer frequency. Life, if it exists near these magma plains, would adapt to heat in remarkable ways. Imagine organisms clustering around volcanic fissures, feeding on chemical energy rather than sunlight. Perhaps microbial sheets cling to warm rocks, glowing faintly with bioluminescence as they metabolize minerals. Perhaps larger creatures, slow, sturdy, heat-tolerant, wander near the plains edges to absorb warmth during cold cycles, their bodies reflecting the molten glow in patterns of dark red and gold. Even the night on a magma world feels different, where Earth's nights are governed by starlight or moonlight. Nights on a magma plain are lit from below. The ground glows softly, illuminating the landscape in warm underlight that casts long, surreal shadows. Mountains become silhouettes outlined with crimson edges. Clouds reflect the molten glow, tinted orange from beneath. It is a world where fire becomes the sun during darkness, a world warmed by its own ancient heart. As you rest deeper into your bed, imagine the slow, smooth motion of these molten rivers. Their warmth radiates gently, their light pulses softly, their movement feels as steady as your breath. There is no fear here, only heat, only time, only the quiet reminder that planets too have life cycles, moments of fire, moments of ice, moments of calm, each unfolding in rhythms far slower than ours. A world where even lava knows how to drift. A world shaped not by chaos, but by the slow breathing of stone. Imagine standing on the surface of a distant world and watching not one, but 2 or even 3 suns rise above the horizon. Their light blends in soft layers, each star casting its own hue, its own warmth, its own quiet influence on the sky. On such planets, worlds orbiting binary or trinary star systems, daylight becomes a moving tapestry. Shadows overlap, colours shift. Time feels braided rather than linear, shaped by the dance of multiple suns across the heavens. Picture the beginning of day. The first sun rises, casting a warm glow across the landscape. Perhaps golden, perhaps pale blue, depending on its temperature. The second sun emerges soon after, adding another layer of light. Where the beams overlap, the ground brightens into a luminous wash. Where they diverge, shadows form in multiple directions, gently stretching and folding like soft brushstrokes across the terrain. A third sun, if present, might appear later, adding a faint silver or red gleam to the sky. On Earth, a single shadow marks our place in the world, but here, your shadow branches into 2 or 3. Each one shifts subtly as the suns take their paths, creating patterns that dance softly across the surface. It feels strange at first, but in a quiet way, as though the planet is inviting you to see time differently, to measure hours not by a single arc of light, but by the layered movements of celestial partners. The sky itself becomes a slow-moving mural. If one sun is a cool red dwarf and another a hotter white star, the blend of their light might tint the atmosphere in complex hues. Lavender mornings, honey-coloured afternoons, pale teal evenings. Clouds drifting through the thick air of a super-Earth reflect these colours in shimmering gradients, glowing brighter at their edges where the light overlaps. Some days, all suns may be above the horizon at once, creating a brilliance that feels almost dreamlike. Other days, one sun may dip below the horizon, while the others continue their watch, leaving the sky half shadowed, half bright. Nightfall on such a world is not a simple act. It arrives in stages. One sun sets, leaving the world slightly dimmer. Another follows hours later, its light fading gently through thick layers of air. Only when the final sun slips away does true night begin, a darkness that feels earned, like the closing of a long layered symphony. The stars of the galaxy emerge then, scattered across the sky in delicate patterns, offering a quiet reminder that even multiple suns are but points of light in a far larger cosmic sea. The climate of these worlds is unique too. Multiple suns can warm the surface in stable, continuous ways, smoothing temperature swings and creating long, gentle seasons. Plants, if they exist, might evolve pigments that shift in tone depending on which suns are in the sky. Broad leaves could absorb different wavelengths of light, shimmering subtly as the spectrum changes. Creatures might become experts at navigating the shifting patterns of shadows, using them to sense time, direction, or the presence of others. As you breathe slowly, imagine how it feels to live under such a sky. The light is always changing, but never abruptly. Transitions unfold in slow, graceful arcs. Shadows lengthen and shorten in overlapping waves. Even your own footsteps cast layered silhouettes that move with soft rhythm, responding to the choreography of the heavens above. A world with multiple suns teaches a gentle lesson. Light is not always singular, time is not always linear, and beauty can come from the harmonious blending of many sources, each adding its own quiet colour to the day. Some worlds wear their beauty openly, not in mountains or oceans or valleys, but in the sky itself, wrapped in sweeping arcs of ice and dust that catch the light like celestial jewellery. These are ringed planets, adorned with luminous bands that stretch across their horizons in broad, delicate curves. On Earth, we admire the rings of Saturn from afar, but imagine living on a super-Earth whose rings shine overhead, not as distant wonders, but as everyday companions. As you breathe slowly, picture yourself standing on such a world. The horizon glows with a soft, diffused light. Even during the day, the rings cast faint reflections across the land, tinting the landscape in gentle shades of pearl, silver, or pale gold. They do not hang directly above you. Instead, they form a sweeping arch that spans the sky, following the planet's curvature. From the surface, they appear impossibly large, stretching from one end of the horizon to the other, a ribbon of light suspended in silence. The rings themselves are made of countless fragments, ice crystals, frozen minerals, tiny shards of rock, each one catching starlight and scattering it into shimmering halos. In thick atmospheres, the light softens as it passes through layers of air, giving the rings a gentle watercolour glow. On a clear day, you might see faint structure within them, bands of brighter ice, darker lanes where dust collects, subtle waves carved by the gravity of hidden moons. At sunrise, the rings ignite. As the star begins to rise, its light grazes the edges of the icy particles, causing the whole arc to shimmer like a quiet firework. The colours shift with the angle of the light. First pale pink, then warm gold, then a soft milky white as daylight settles in. Shadows of the rings fall across the planet in wide, diffuse lines, creating patterns that drift slowly across plains and oceans as the planet rotates. At night, the rings transform again. Instead of reflecting sunlight, they catch the faint glow of starlight, or even the planet's own reflected illumination. They appear softer, dimmer, more intimate, like a thin veil of silver dust brushed across the sky. If the world has multiple moons, their silhouettes drift across the rings in quiet procession, creating moments of gentle eclipse. The climate of a ringed super-Earth can be shaped by these luminous bands. Rings can cast long seasonal shadows across the planet, cooling certain regions slightly, creating soft gradients in temperature. They may also reflect light downward, brightening nights with a diffuse glow that never fully fades. Imagine a world where night is rarely completely dark, where the rings provide a kind of permanent twilight, soothing and pale, like moonlight stretched across the sky in a continuous sheet. Life on such a world might evolve under this gentle illumination. Plants could adapt to take advantage of the extended light, growing broader leaves or developing pigments tuned to the soft glow of ring light. Animals might learn to navigate using the patterns of the rings, their brightness, their shadows, their seasonal shifts. Even intelligence, if it arises, might be shaped by the constant reminder of beauty arching overhead, a daily brush with cosmic grandeur. As you rest deeper into your pillow, imagine lying on a quiet hillside and watching the rings shimmer above you. The air is cool, the sky is deep, and the arc of ice and dust feels like a calm, luminous river flowing silently overhead, a presence that is always there, always moving, always gentle. A horizon decorated with light, a world that wears the cosmos like a crown. Some planets feel as though they are always holding themselves softly together, wrapped into layers of air so thick and nurturing that sunlight arrives not in sharp beams but in wide, muted waves. These are worlds with dense atmospheres, protective shells that trap warmth, soften weather, and give every moment beneath their skies a gentle, enveloping quality. On a super-Earth, where gravity holds air close and pressure rises steadily, such atmospheres can create landscapes that feel almost dreamlike. Imagine taking a step onto such a world. The air greets you immediately, warm, dense, almost velvety. It presses lightly against your skin with a sensation not unlike wading into warm water. Your breath feels fuller, slower, more deliberate. Sound behaves differently here too. Words drift only short distances before dissolving. Wind moves with a heavy hush, spreading its presence rather than slicing through the air. The entire planet seems wrapped in a soft quiet, as though every noise has been lowered by a single gentle note. Sunlight that reaches the ground has been filtered through thick layers of atmosphere. Instead of sharp brightness, you see glow, diffuse and calming, like morning light shining through fog. Shadows have soft edges. Colours appear warmer, smoother, more blended. If the sky contains mineral dust or exotic gases, the light might shift subtly throughout the day. Honey-toned at noon, muted rose in the evening, pale lavender just before nightfall. Clouds form easily in such conditions. They gather in broad, layered sheets that stretch across the sky in slow, sweeping formations. Unlike Earth's rapidly shifting patterns, clouds on a thick atmosphere super-Earth move with patient grace. Their lower layers cast gentle shade over the land, while their upper levels catch sunlight and scatter it like fine mist. During storms, which unfold not with violence but with slow intensity, rain falls in heavy, warm droplets that descend in unhurried rhythms. Because thick atmospheres retain heat so effectively, temperatures rarely swing wildly. Nights cool only gradually, carrying the memory of the day's warmth. Even in regions far from the equator, cold is softened by insulation. Seasons blend into one another, defined more by subtle changes in humidity or cloud patterns than by dramatic shifts in temperature. Plant life, if it exists, might thrive here with exuberant calm. The filtered light encourages broad, wide leaves designed to absorb every softened photon. Colours might be darker or richer than Earth's foliage, reflecting adaptations to the dimmer illumination. Forests on such a world could resemble vast, sprawling canopies. deep, shadowed groves where moisture hangs in the air and every breath smells of soil and mineral-rich fog. Animals would evolve differently too. Wings might be broader, taking advantage of the dense air for slow gliding movements. Bodies might be compact, strong and efficient, adapted to higher atmospheric pressure. Communication could rely more on low-frequency vibrations than on sound, allowing voices to travel through thick air with soothing clarity. Even water behaves differently beneath such skies. Lakes reflect sunlight like brushed metal, smooth and calm, barely disrupted by wind. Waves move slowly, as though pushed through syrup. The air above them remains warm and humid, creating halos around the horizon where water vapour blurs the boundary between land and sky. As you rest deeper into your pillow, imagine the comfort of standing on one of these worlds. The air thick and warm around you, light arriving in softer layers, every movement slowed into calm. The planet feels like it is holding you gently, wrapping you in its atmosphere the way a blanket wraps a sleeping body. A world where the sky is not simply above you but around you, embracing, protective, serene. Seasons on Earth are familiar chapters, spring budding with warmth, summer glowing with fullness, autumn softening into gold, winter falling into stillness. But on distant super-Earths, the rhythm of seasons can unfold in ways far stranger and far slower. Long, drifting waves shaped not only by tilt and orbit, but by gravity, atmosphere, and the whims of an unfamiliar sun. A year on such a world might last twice as long as ours, or 10 times, or only a few days. Time becomes fluid, stretching and compressing like breath. Imagine standing on a super-Earth with a gentle axial tilt. Here, the seasons change so slowly that a single transition can last decades. Spring does not burst forth. It unfolds in soft gradients, barely noticeable day to day. Temperatures climb in quiet increments. Flowers, if they exist, bloom not in sudden clusters but in slow spirals, appearing one by one as if reluctant to disturb the tranquility. Forests shift colour gradually, leaves deepening or paling over long cycles shaped by the filtered muted light. On worlds with stronger tilts, seasons become more dramatic but still hold the calm signature of thicker atmospheres and steady climates. Summers might be warm and humid, with towering cloud layers collecting moisture and releasing it in steady sheets of rain. Winters might bring wide, slow-moving snowstorms, flakes descending with heavy grace through dense air settling gently on forests and plains. The pace of weather is never hurried. It drifts. Some worlds orbit faint stars, requiring them to stay close for warmth. On these planets, seasons may feel like extended sunrises and sunsets. A year might pass in perpetual twilight, with the angle of the star shifting slightly but never rising high enough to create harsh noon sunlight. Imagine a world where spring and autumn blend seamlessly, any distinction softened into a long amber-hued glow. Other planets orbit 2 or more suns, creating seasons that respond not only to tilt, but to the gravitational dance of stars themselves. Temperature patterns rise and fall in complex rhythms, with warm periods arriving as suns approach each other in the sky, and cooler periods settling in when their light diverges. On such worlds, seasons might carry the shimmer of overlapping shadows, or the flicker of multiple sunsets layered on top of one another. And then there are tidally locked worlds, where traditional seasons vanish entirely. Instead of spring, summer, autumn and winter, life adapts to gradients. Hotter near the unchanging sunlit side, colder near the perpetual dark. The Terminator region, the narrow ring of twilight, becomes a constant zone of mild temperatures. Here, change is not measured in seasons but in subtle shifts in wind, cloud formation, and the slow stirring of atmospheric currents. Life on these worlds must find its own rhythm. Plants may grow to match the rhythm of long days and longer nights. Some might sleep through entire decades of cold, only to awaken when warmth returns. Others might grow continuously under dim, steady light, becoming tall and spiraled, shaped by years without darkness. Animals may migrate not yearly, but once or twice in a lifetime, following the slow march of temperature bands across the planet. As you breathe deeply now, imagine the serenity of such a world, a year that moves in long, slow currents, seasons that drift like tides. Time itself stretching out, smoothing your thoughts the way a calm ocean smooths its surface after a passing wind. There is no rush here, no sudden change, only cycles whispering through millennia, guiding life in patient, gentle rhythms, a world where the seasons breathe slowly, and where every year feels like a long, soft exhale. Life, as we know it, clings to warmth. On Earth, that warmth often comes from the sun. But there are other kinds of warmth, quieter, deeper, more ancient, rising from the heart of the planet itself. And on many alien worlds, especially super-Earths wrapped in ice, or smothered in unbroken cold, this is where life may gather, not on the frigid surface, but far beneath it, in hidden oceans and luminous caverns warmed by the gentle persistence of geology. Imagine kneeling on the frozen crust of a distant super-Earth. The world above is silent, wrapped in perpetual frost. Snow falls slowly through dense air, drifting like powdered starlight. The horizon glows faintly, reflecting the muted colours of a distant sun. To an outside observer, the planet may seem lifeless, a frozen orb with no forests, no oceans, no movement at all. But beneath your feet, unseen warmth flows. Tidal forces from the planet's star or from neighbouring moons knead the interior like soft dough, generating frictional heat. Radioactive minerals release their slow, steady energy. Pressure builds and breaks, cracking the ice in patterns that grow and shift over centuries. Through these cracks, heat rises, melting small pockets that expand into vast hidden seas. And in these dark oceans, life may begin its patient work. Now imagine slipping beneath that frozen shell. The darkness is absolute at first, thick, velvety, comforting. But as your eyes adjust in this imagined space, faint glimmers appear. Soft points of blue and green light drift through the water like wandering stars. These are not reflections, they are creatures, bioluminescent life. Organisms shaped by chemical energy rising from volcanic vents below. On Earth, such ecosystems thrive without sunlight. Bacteria feed on minerals released from the vents. Tube-like organisms gather around them, creating slow-moving forests of soft, waving forms. On a super-Earth, the pressure and chemical richness could produce even more complex structures. Glowing mats that ripple when currents pass through them, delicate branching organisms that pulse with dim light, or wide membranous creatures drifting like living lanterns. Hydrothermal vents might tower like dark cathedrals, glowing faintly from mineral deposits. Warm currents spiral upward, carrying nutrients into the cold water above. Life gathers in these oases, not in frantic swarms but in quiet constellations. Communities shaped not by speed, but by the slow stability of geological warmth. Even the ice above participates in this ecosystem. Cracks form from tidal stresses and refreeze slowly, letting tiny amounts of nutrient-rich water rise and fall. Over centuries, these movements carve patterns in the ice. Frozen rivers, translucent channels, and shimmering sheets that glow softly with trapped bioluminescence. It is a world where geology, chemistry, and biology blend into a single, gentle rhythm. If intelligent life ever arose in such a place, it would see the universe differently. The concept of day and night would be meaningless. Time would be measured in currents, in vent cycles, in the slow migration of heat through rock and water. Language might revolve around temperature, flow, and pressure. Light, when it appears, would be a miraculous thing. produced by living bodies, shared between organisms like whispered secrets in the dark. As you breathe softly, imagine floating in this hidden ocean. The water is warm, the darkness is comforting. The glow of distant organisms pulses in steady, soothing rhythms. Above you, kilometers of ice filter the faintest hint of starlight, turning it into a soft, ghost-like glow. The entire world feels quiet, ancient, cradle-like, a place where life persists not because conditions are perfect, but because warmth, even hidden warmth, is enough. A reminder that life does not always need sunlight. Sometimes it only needs a small whisper of heat in the dark. Not all life needs solid ground. On some worlds, the atmosphere itself becomes an ocean, dense, warm, and buoyant, capable of lifting living creatures the way water lifts jellyfish or drifting plankton. In these thick skies, where air behaves almost like a fluid, evolution may take a very different path. Instead of legs or fins, bodies may grow broad membranes, gas-filled chambers, or intricate frills designed to catch slow, rising currents. Here, in the soft embrace of a dense atmosphere, life may float rather than walk. Imagine standing on the surface of a super-Earth where the air is 2, 3, even 5 times denser than Earth's. The sky feels close, warm against your skin. Your breath moves through it with gentle resistance, as if pushing through velvet. Above you, clouds hang low and heavy, drifting in wide layers rather than high towers. If you listen carefully, you might hear a distant rhythmic flutter, not wings beating against the air, but bodies riding it, gliding as if weightless. Now imagine looking upward and seeing creatures suspended in the thick atmosphere. Some might be shaped like translucent sails catching warm updrafts that rise from sunlit plains. Others could resemble floating lanterns, with wide, rounded bodies filled with lighter-than-air gases produced through slow, biological processes. These organisms do not fly in the way birds fly. They do not struggle against gravity. Instead, they partner with their world's dense air, drifting, rising, and sinking with the calm patience of clouds. Their movements are slow, graceful, and deliberate, gliding arcs instead of flapping, soft rotations instead of sudden turns. Some may move by adjusting internal buoyancy, contracting chambers to descend, expanding them to rise. Others might steer by shifting fluid through membranes, creating subtle changes in density. Beneath them, their shadows drift across the ground in elongated shapes, stretching and folding gently in the diffused light. Life in the lower atmosphere could take different forms altogether. Imagine sky forests, colonies of plant-like organisms anchored to nothing, drifting in thick layers of clouds. They might absorb nutrients from airborne particles, moisture, and sunlight filtered through the atmosphere. Some could glow faintly, bioluminescent streaks lighting up the sky at dusk like slow-moving constellations. These floating ecosystems might stretch for kilometers, forming vast aerial fields that shift with the weather. Predators, if they exist, would move with careful elegance. Perhaps they have long tendrils trailing behind them, capturing smaller floating organisms the way Earth's jellyfish gather drifting prey. Or maybe they use sound, low, resonant pulses that travel well through thick air, to navigate, communicate, or stun smaller creatures. Even microbial life could live suspended in the atmosphere, forming drifting clouds of colour or faintly shimmering patterns visible only when sunlight hits at the perfect angle. The climate of such worlds nurtures this airborne existence. Warm ground heats the air above, sending slow, powerful updrafts upward like invisible rivers. These currents might carry organisms from one region to another, allowing entire ecosystems to migrate with the seasons, moving not across land, but through the sky itself. On worlds with thick atmospheres and gentle winds, floating life could flourish for millions of years without ever touching the ground. As you breathe deeply now, imagine lying on a quiet hillside, gazing upward at this serene sky. The creatures drift overhead like living balloons, their bodies shimmering softly in the filtered light. They move with the slowness of dreams, painting gentle paths across the heavens. The air around you feels thick and warm, carrying the faint scent of minerals and cloud-born life. A world where the sky is not empty space, but a floating forest, a drifting ocean. A cradle for life that rises instead of walks. Some worlds bloom not in daylight, but in darkness. When the sun sets, or when perpetual twilight deepens, the landscape begins to shimmer with life that creates its own glow. On these planets, bioluminescence becomes not a rare trick or a curious accident, but a universal language shared across oceans, forests, and drifting skies. Light becomes communication, light becomes survival, light becomes beauty. Imagine standing on the surface of a super-Earth as night begins its slow descent. The sky dims into deep cobalt, the air thick and warm, carrying the scent of alien plants. The ground beneath you looks quiet at first. Dark shapes, muted colours, silhouettes softened by a dense atmosphere. But then, as your eyes adjust, faint glimmers appear, a spark, a ripple. A drifting wave of gentle brightness, and soon the entire landscape begins to glow with life responding to life. On such worlds, bioluminescence may evolve easily. A thicker atmosphere traps moisture and cools nights gradually, creating environments where glowing organisms can signal across vast distances without losing their light too quickly. Minerals suspended in the air refract faint illumination. Warm seas allow chemical reactions to proceed steadily. Forests hold humidity close, nourishing communities that produce light as effortlessly as earth plants produce scent. Picture fields of plant-like organisms whose leaves pulse with shifting patterns. Blue waves signalling moisture, green flickers marking nutrient flow, violet spirals indicating growth. These pulses move slowly across hillsides, creating the illusion of thought spreading through the landscape. Yet nothing is rushed. Every pattern unfolds with dreamlike calm, as if the world is thinking in long, soft breaths. Now imagine creatures moving through this bioluminescent forest. Some glow continuously, casting halos around their bodies like lanterns. Others flash in quiet rhythms to communicate. A slow flicker meaning comfort, a gentle ripple meaning curiosity, a bright pulse meaning caution. Their bodies may be translucent, letting internal organs cast faint shadows through their glowing tissues. Motion here is poetry, written in light. In the oceans, the glow becomes even more mesmerizing. Millions of drifting organisms shimmer with soft blue light as waves move across the surface. When currents stir the water, entire regions ignite in rolling luminescent tides, as if the sea itself is inhaling and exhaling brightness. Larger creatures might carry trails of light behind them, tracing slow arcs like comets gliding through water. Deep beneath the surface, towering forests of soft coral analogues pulse gently, filling the darkness with shimmering constellations. Even the sky participates. Remember the thick atmosphere of many super-Earths. Warm, humid, dense. In such air, microscopic organisms might drift in cloud layers, glowing faintly like floating fireflies. During certain seasons, winds could gather them into vast luminous veils that stretch across the horizon. Imagine looking upward at night and seeing bands of light trailing across the sky, not from stars but from living clouds illuminated from within. The purpose of this glow could vary. Some organisms communicate through light, others lure prey. Some may camouflage themselves by matching the faint luminance of their surroundings, and some may glow simply, because their chemistry produces energy in ways that make light a natural byproduct, a quiet miracle encoded in their biology. As you breathe deeply, imagine this world all around you, a place where darkness is never complete, where night is a canvas painted by the slow drifting dance of living light, where every flicker, every pulse, every shimmering thread feels like a thought moving gently through the air. It is peaceful here, soft, alive in the quietest way possible, a world where light isn't just something the sun provides, but something life dreams into existence. Up to this point, we've wandered through quiet possibilities shaped by geology, atmosphere, and light. But there is another question that drifts softly at the edge of our imagination. If life truly thrives on some of these distant worlds, could any of it have learned to build, to think, to shape its environment the way we do? Imagine a super Earth where evolution has unfolded for billions of years under stable conditions, mild temperatures, abundant water, thick atmosphere, and slow, gentle seasons. If intelligence were to arise there, it would be shaped by forces different from those that shaped us. Its senses, its body, its movement, and even its concept of time would reflect the world that cradled it. Picture an alien civilization on a world with heavier gravity. Bodies might grow low and strong, built to thrive under the planet's steady pull. Their movements would be deliberate and grounded, not rushed. Perhaps they perceive subtle vibrations in the dense atmosphere, giving them a natural language woven from low-frequency sounds. Their architecture might hug the ground, rounded structures that distribute weight evenly, shaped by an understanding of their planet's pressure. Or imagine a world wrapped in constant twilight, orbiting a dim red dwarf. Here, vision may evolve not around sharp lines and bright colours, but around contrast and motion. Buildings might glow softly with bioluminescent materials, merging seamlessly with the environment. Streets could wind in gentle curves that reflect the slow drift of winds and clouds. Instead of seeing life as a struggle against darkness, such beings might view the dim light as a blessing, a backdrop for glowing art, shifting patterns, and quiet communication. What about a planet with dense skies where floating life evolved? Intelligent beings there could be aerial or semi-aerial, navigating three-dimensional space as easily as we walk on flat ground. Their cities might not rest on land at all, but float within thick atmospheric layers, drifting platforms anchored by buoyant gases or organic materials. Homes could resemble gently moving gardens, drifting with the weather. Music might be shaped by the dense air, creating rich, resonant tones that vibrate through their whole bodies. In frozen worlds with subsurface oceans, intelligence might develop underwater. Imagine beings who navigate complex currents, communicating through pulses of bioluminescence and subtle shifts in water pressure. Their understanding of the universe would be shaped by darkness, silence, and the quiet glow of life around them. Tools might be grown rather than built, shaped from organic materials adapted to pressure and temperature. Cities could evolve in underwater caverns warmed by hydrothermal vents, glowing living structures that pulse softly with energy. And then there are civilizations shaped by multiple suns. Time here would not follow a singular rhythm. Seasons might be defined by the paths of 3 stars weaving their light across the sky. Cultures could develop rich symbolic traditions around overlapping shadows and triple sunsets. Architecture might be designed to catch and refract the constantly shifting colours, making the entire city glow like a jewel as the suns pass overhead. Across all these possibilities, one idea remains gentle and universal. An alien civilization would not be a stranger to its world. It would be at home in ways we cannot fully imagine. Its myths, its art, its tools, its dreams, all would arise naturally from the planet that shaped it. And perhaps, somewhere in the galaxy, beings like these may already look up at their own skies, sapphire, amber, violet, or dusk blue. and wonder if someone else is out there looking back. As you breathe softly now, let that possibility drift around you like mist. The idea that intelligence is not an Earth-exclusive gift, but a quiet potential carried by many worlds. Every world has a voice, not always loud, not always familiar, but always present, written in wind, pressure, temperature, and the subtle vibrations of rock and air. On distant super-Earths, these voices might whisper in tones we have never heard before, shaped by atmospheres thicker or thinner than our own, by gravity that presses air into dense layers, or by oceanic mist that softens sound into gentle murmurs. Each planet becomes an instrument played by physics itself, producing soundscapes that drift, hum, and resonate beneath alien skies. Imagine standing on a world with a dense atmosphere. The air presses warmly around you, thick enough to feel almost tangible. When the wind moves, it doesn't whip or whistle. It flows, creating deep, resonant vibrations that roll through valleys and over plains like distant thunder softened into song. A simple breeze may sound like a low hum. Stronger winds might produce layered tones, each frequency shaped by the contours of mountains and the mineral content of the air. Even your own footsteps feel muffled, swallowed quickly by the thick atmosphere, giving the world an intimate, quiet-hearted presence. On a world with thin air, the soundscape changes entirely. Noise carries poorly, dissolving almost as soon as it forms. A gust of wind becomes a faint hiss, fragile and fleeting. Rocks cracking under temperature, shifts echo across greater distances, sharp and clear. If there are creatures here, their calls may be high-pitched or rhythmic, designed to travel through sparse air like delicate threads of vibration. Silence feels less like an absence and more like a spacious stillness, a wide-stretching quiet that frames every sound with clarity. Some super-Earths may have massive cave systems beneath the surface, carved by water or volcanic activity. Inside these caverns, sound would resonate deeply. Drips of mineral-rich water could echo in long, soothing patterns. Shifts in rock might create gentle groans, like the planet breathing slowly. Air travelling through narrow passages may produce soft, flute-like tones, whispering secrets from deep within. Imagine standing in a cavern lit by bioluminescent fungi or crystals, listening to echoes that repeat slowly, each one slightly transformed by the chamber's shape. And then there are the worlds thick with life. Imagine walking through a twilight forest filled with plants that vibrate in response to wind, producing gentle chiming sounds as their membranes flutter. Or perhaps creatures communicate through low-frequency pulses that travel through dense air and soft soil, creating rhythmic patterns felt more in the chest than in the ears. Some organisms might glow as they sing, pulses of light synchronized with quiet, resonant tones, turning communication into a dance of luminescence and sound. Oceans too create unique voices. On water worlds, waves may move slowly under stronger gravity, producing deep, steady booms that roll through the air like the heartbeat of the sea. Thermal vents might crackle softly beneath the surface. Floating life forms could tap, click, or hum in long-distance communication, their sounds drifting upward to the air above. When rain falls, heavy, warm, and slow, it creates patterns on the water that resemble rhythmic tapping, each droplet resonating differently depending on mineral content and atmospheric density. Even atmospheric lightning, shaped by exotic chemistry, may create unfamiliar tones. Perhaps wide, slow rumbles that echo for minutes. Perhaps high, crystalline snaps caused by charged particles moving through thick clouds. Or perhaps something entirely new, a blending of frequencies impossible on Earth. As you breathe gently now, imagine closing your eyes on such a world. You feel the wind humming around you. You hear distant tones echoing across wide valleys. You sense the deep patience of a planet expressing itself through air and stone. Sound becomes touch, touch becomes atmosphere, and the rhythm of the world settles into your breath like a lullaby drifting through cosmic air, a reminder that every world sings, some in melodies, some in murmurs, all in their own slow ancient rhythms. Night is familiar to us, a dark canvas, a scattering of stars, constellations shaped by ancient stories. But on distant super-Earths, night can unfold in ways both breathtaking and completely foreign. A sky filled with unknown constellations, stars arranged in patterns no human imagination has ever traced, galaxies appearing brighter or fainter depending on the atmosphere, and moons, perhaps many of them, drifting like glowing beads along invisible threads. Imagine standing on an alien world as night settles gently across its horizon. The air cools but retains warmth, thanks to a thick, embracing atmosphere. A soft breeze carries scents you cannot place. Minerals, moisture, unfamiliar vegetation. Slowly the sky darkens, not into blackness, but into a deep velvety hue shaped by the world's air and its sun's fading light. Then the first stars appear. Not the stars you know, not Orion, not the Big Dipper, not the Southern Cross, but new configurations, brighter, stranger, untouched by myth. Some stars appear sharper due to clearer air. Others shimmer with subtle colours, blues that verge into turquoise, reds that pulse faintly, pale violets that seem almost liquid. If the planet orbits a dimmer star or lies closer to the galactic plane, the Milky Way might blaze across the sky as a dense, luminous river. On worlds with thinner atmospheres, the night sky could appear almost overwhelming with clarity. On those with denser air, stars look softened, like lanterns glowing from behind sheer curtains. Now look for moons. Many super-Earths may have several, small ones, large ones, icy ones casting glowing reflections onto the landscape. Imagine 3 moons rising together in quiet choreography, each one tinted differently by the world's atmosphere. One pale silver, one warm peach, one deep blue. Their combined light falls softly across oceans and plains, casting layered shadows that shift as the moons move in their long synchronized paths. And then imagine the rings from earlier sections, if they exist, glowing faintly across the night like a soft arch of powdered light. Their reflection mixes with moonlight and starlight, creating a horizon that shimmers even in darkness. Nights here are not empty. They are textured, layered, alive with quiet luminosity. Some worlds may orbit binary or trinary stars. When the suns finally set, their afterglow lingers differently. Perhaps one star fading quickly, another sinking more slowly, leaving gradients of colour long after darkness arrives. The residual glow could paint the sky in amber or lavender tones, merging smoothly with the incoming starlight. Even after night fully settles, a faint halo may remain near the horizon, a reminder of daytime warmth. On tidally locked worlds, the night side is eternal, an endless, star-filled expanse. Standing there would feel like stepping into infinity. The stars never shift from their positions. Galaxies remain fixed. Time seems to stop. On these planets, civilizations might navigate by the unchanging sky, using constellations as maps that never drift. Creatures, if present, may evolve senses that thrive in this stable darkness. Some might see well beyond the human visible spectrum, perceiving ultraviolet patterns or infrared signatures cast by living organisms. Others might navigate by detecting starlight reflections off ice or mineral surfaces. Even plants could glow faintly, reflecting moonlight or storing bioluminescent minerals gathered from the ground. As you breathe slowly now, imagine lying on a quiet meadow under this alien firmament. The grass, perhaps tinted violet or teal, shifts softly in the breeze. The constellations above feel like messages written in a language you almost understand. The sky seems larger than anything you've ever known, yet strangely comforting. A reminder that the universe holds more beauty than our minds can easily hold. Here, beneath constellations no human has named, you feel a gentle truth. Every world has its own sky, every sky its own stories, and somewhere beneath unfamiliar stars life may be looking upward too. On Earth, the rhythm of a day is so familiar that we hardly notice it. Sunrise, morning, noon, evening, night. A steady cycle repeating every 24 hours, shaping sleep, wakefulness, seasons, and the quiet pulse of life. But on distant super-Earths, time may flow to a very different rhythm, dictated by the planet's rotation. Some worlds spin so slowly that a single day can last months. Others spin quickly, turning through many days in the time Earth measures as one. And on tidally locked planets, as we explored earlier, a day may never pass at all. Imagine standing on a world where the rotation is slow, unbelievably slow. The sun rises not in minutes, but over the course of several days, appearing first as a faint glow on the horizon. The light strengthens so gradually that it feels like watching a long-held breath. Shadows shift almost imperceptibly. Morning lingers for weeks, casting soft gold over plains and mountains. Animals evolve to thrive in these extended dawns. Plants open slowly, absorbing the low, steady light. Entire ecosystems synchronize with these drawn-out transitions. Midday becomes a season unto itself. Long hours or days of steady warmth and bright sky. Creatures find shade in burrows or beneath broad leaves. Winds change direction as the temperature gradient shifts with patience. Rivers may swell during these warm stretches, fed by glacial melt from regions still emerging from a frozen night. Then, slowly, evening arrives. Sunlight dims over days, painting the sky in colours that blend and stretch into one another. Twilight lasts so long it feels eternal, casting the world into a serene, reflective glow. Nights on such planets are equally extended. Long stretches of cool calm where temperatures drop gradually, never abrupt. Life on these slow-rotating worlds adapts in fascinating ways. Sleep cycles might become flexible, unbound to the strict schedule of rising and setting suns. Some organisms might rest in short intervals throughout the long day. Others might remain active until the world grows too warm or too cold, then retreat into periods of stillness. Plants might grow in slow spirals, tracking the sun through its marathon arc across the sky. Now imagine the opposite, a world that spins quickly. Here, day and night rush past at dizzying speed. Sunlight flickers in patterns that change hourly. Winds form intense but short-lived cycles. Temperatures rise and fall rapidly, creating weather that feels lively but unpredictable. Life would need fast reactions. Quick-growing plants, alert creatures, ecosystems built on speed and resilience. And then there are the worlds where rotation is balanced delicately with orbit. Worlds with resonant cycles. For example, a planet may rotate exactly twice for every 3 times it orbits its star, creating complex day-night patterns. Some regions experience normal cycles, while others fall into long periods of light or shadow depending on latitude. Time, in these strange zones, becomes a patchwork. Entire cultures, if they exist, might measure life not by hours or days, but by light cycles unique to their region. On tidally locked worlds, of course, time becomes something else entirely. The star never rises. The star never sets. One half of the planet basks forever in daylight. The other sleeps forever in night. Only the twilight band feels the passage of time through shifting winds, gentle gradients, and the soft evolution of clouds. As you breathe slowly now, imagine letting go of Earth's familiar rhythm. Feel your mind drift into a world where time stretches like warm taffy, slow, steady, unhurried, or into a world where days flutter past like the wings of insects. or into one where day and night lose meaning altogether, replaced by cycles of warmth and cool, light and shadow, movement and stillness, a reminder that time is not universal. It is carved by each planet's spin, shaped by its star, and felt differently by every creature that calls it home. After wandering through so many super-Earths and alien landscapes, a deeper question begins to gather in the quiet space between thoughts. What makes something a world? Is it size, mass, composition? Or is it something softer, something more like the way light settles across its surface, the way gravity holds it together, or the way life, if present, learns to breathe within its rhythms? Imagine floating gently above a newborn planet. The star behind you paints the surface in soft gradients of gold and warmth. Below, molten rock cools slowly, forming crust, valleys, and potential oceans. The atmosphere thickens from gases rising through volcanic vents. The world is not yet a place, not yet familiar, but you can already sense its identity forming, shaped by rotation, illumination, and chemistry. A world begins not with life, but with possibility. Now imagine drifting above an ancient planet. Its mountains are low, worn by eons. Its oceans may have shifted 1,000 times. Its climate has drifted in slow spirals. Everything solid carries the memory of billions of years. Yet the same question remains. Is this world defined by its history, or by the way it holds silence, light, gravity, and time together? Perhaps a world is simply a place where light decides to rest, where photons strike rock, water, or ice, and leave traces of warmth. Every sunrise is a negotiation between star and surface. Every sunset is an agreement that the exchange will begin again. A world is a stage for illumination, for reflection, for the long conversation between energy and matter. But there is more to it than physics. A world becomes meaningful when something within it notices the light. When a plant grows toward it, or a creature senses warmth, or an intelligent being looks upward and wonders where the glow came from. Awareness transforms geology into setting, planet into home. Even lifeless planets carry a quiet story. The swirl of storms across Jupiter's atmosphere, the deep red deserts of Mars, the ice plains of Europa, the methane seas of Titan. Each is a world because each holds its own equilibrium, its own dance between gravity, atmosphere, heat, and time. On super-Earths, that equilibrium might be even more varied. A world of endless ocean is still a world, even without land. A planet glowing from within has a story shaped by heat and pressure. A frozen giant carries layers of time in its ice. A ringed super-Earth, adorned with bands of starlit dust, expresses itself through reflected brilliance. These worlds differ wildly, yet each is complete in its own way. So perhaps a world is not defined by similarity to Earth, not by habitability, not by familiarity, but by wholeness. By the way all of its forces align to create a single, coherent presence, a kind of cosmic personality. Some worlds breathe warmth, some breathe cold, some breathe silence, some breathe storms. A world is a place that holds itself together and carries its identity through the vastness of space. As you breathe slowly now, imagine all the worlds we've drifted through tonight. Ocean worlds without shores, frozen planets wrapped in ancient ice, skies filled with floating life, landscapes glowing with bioluminescent forests, horizons crowned with shimmering rings. Each one is a world because each one shapes light in its own way, giving every moment a distinct character. A world is where physics becomes experience, where matter becomes meaning, where silence becomes story. Between all the worlds we've imagined tonight, between the super-Earths, the frozen giants, the glowing magma plains, the ringed horizons, the twilight zones, there stretches a vastness so deep and so quiet, that it almost feels like another presence entirely. This is the interstellar space between stars, a place of profound silence where light travels uninterrupted for trillions of kilometers and time seems to drift without resistance. It is here, in this quiet, that every possibility rests. Imagine floating gently in the space between two distant suns. There is no wind, no ground, no sound, only the soft hum of your own breath and the faint glow of stars scattered across a velvet darkness. The nearest sun is only a pinprick of light, yet its warmth, its planets, its storms, its histories all remain out of reach, suspended in stillness. In the other direction, another sun gleams faintly, surrounded by unseen worlds, unseen skies, unseen life. You are suspended between them, held by nothing, surrounded by everything. The silence here is not empty, it is patient. It carries the memory of all stars that have ever burned and all planets that have ever formed. It holds the raw material for future worlds, dust, gas, the remnants of supernova drifting in thin wisps. Here, new solar systems begin, collapsing slowly into disks of swirling matter, eventually giving birth to planets that will one day hold oceans, mountains, clouds, perhaps even consciousness. This quiet space is the cradle of cosmic creation. If you breathe softly now, imagine listening to this silence, not with your ears, but with your imagination. In the stillness, you may sense faint echoes, the residue of ancient starlight, the soft ripple of gravitational waves passing through, the lonely whispers of particles drifting aimlessly for centuries. Space is silent not because nothing happens, but because everything happens too gently to be heard. In this silence, worlds wait. A world forming around a distant star might be gathering mass at this very moment. A world in another system may be cooling after 1 billion years of volcanic heat. A world on the far side of the galaxy may be experiencing its first rainfall, its first cloud, its first chemical spark of life. And the silence between them connects everything, not through sound, but through existence. Even civilizations, if they are out there, drift in this quiet. One might be sending faint signals through radio waves, humming across the void like messages in bottles. Another might be listening patiently for whispers from the dark. The distance between stars makes conversation nearly impossible, yet the possibility remains like a soft candle flame in a vast room. This interstellar quiet also shapes how we think. It reminds us that life on Earth, and life anywhere, is not isolated. It is part of a cosmic story written in silence scattered across millions of worlds. We are a single note in a symphony played over billions of years. The stillness between stars is the rest, the pause that gives meaning to the music. As you rest deeper into your pillow, imagine drifting slowly through this cosmic silence. Stars pass by like slow-moving lanterns, nebulae glow in pale blues and pinks. Dark dust clouds stretch like soft ink across the sky. Everything feels far, yet everything feels connected. A gentle truth settles here. The silence between stars is not emptiness, it is potential. The quiet place where worlds are born, where ideas take shape, where possibility breathes. After drifting through alien skies and quiet oceans beneath ice, through glowing forests and worlds with 3 shadows, your thoughts may begin to circle back home, back to Earth, this small blue sphere drifting through a spiral arm of the Milky Way. For all the beauty we've imagined in distant worlds, there is something quietly extraordinary about the one we live on. Earth is not perfect. It is not the only habitable world. But it is precisely balanced in ways that feel almost miraculous. Imagine Earth from afar, a pale blue orb suspended in the dark, oceans swirling with currents, clouds drifting in soft spirals, a thin atmosphere glowing faintly along the edge, like a halo of breath around a living creature. In the vast cold between stars, Earth is warm. In the quiet vacuum of space, Earth is full of sound. Waves, wind, voices, laughter. It is rare not because such balance is impossible elsewhere, but because so many things have aligned here so gently, so precisely, for so long. Consider our sun. Not too hot, not too cool. Steady and calm compared to many stars. Its light falling at just the right distance to create liquid water. Not frozen, not boiling, but flowing, shaping rivers and seas and clouds. Our orbit is almost circular, smoothing out seasonal extremes. Our rotation is steady, giving us days short enough to energize life yet long enough to allow rest. Consider our moon, a companion so large it stabilizes Earth's tilt, keeping seasons predictable. A body whose tides stirred early oceans, mixing nutrients and helping life flourish. A silent guardian shaping our rhythms, influencing migration, even inspiring stories written in moonlit ink. Consider our atmosphere, thin enough to let starlight through, thick enough to warm us, to shield us, to carry clouds and sound and breath. A mix of gases kept in delicate balance by oceans, plants, geology, and life itself. A system so finely tuned that small changes ripple across the whole world. Consider our magnetosphere, an invisible shield that deflects cosmic radiation and solar wind. A force field generated by Earth's molten core. One more quiet miracle beneath our feet. All these factors, and millions more, weave together into a planet that supports forests, coral reefs, deserts, rainstorms, birdsong, human thought, and all the quiet moments you have ever cherished. Earth is not alone in its potential, but it is uniquely ours. Every breath you take is connected to oceans and leaves and sunlight that travelled across 150 million kilometres to reach you. Every landscape you've ever walked through, mountains, beaches, city streets, quiet fields, exists because of a balance that holds strong even as it shifts, adapting and changing over billions of years. As we imagine distant worlds, we often feel a mix of wonder and humility. The universe is vast enough to hold countless planets, many with conditions that defy our expectations. Yet Earth remains the only place we know where minds can look up at the sky and ask questions, where emotions and memories shape our experience of planets and stars, where we dream of other worlds while living fully in this one. As you breathe slowly now, let that truth settle gently in your chest. Earth is not rare in a cosmic sense. Countless planets exist. But it is rare in the sense that it is home. It is the world that knows you, the world that shaped your ancestors, the world that gives you air, warmth, and the sky you recognize. A small miracle of balance, a quiet, steady cradle in the vastness of space. After drifting so far from home in imagination, past super-Earths wrapped in thick air, past frozen oceans glowing from beneath, past skies filled with floating life and valleys humming with alien winds, something gentle begins to happen. You start to see Earth and yourself more clearly. Alien worlds are not just destinations for curiosity. They are mirrors. They show us what makes life precious here, what makes us fragile, and what makes us extraordinary. Imagine all the planets we visited tonight arranged before you like pages in a storybook. Each one tells a tale of possibility, a world where light is constant and shadows never move, a world where life drifts in dense air like lanterns, a world where bioluminescent forests pulse like slow thoughts, a world where sky rings arc across the horizon, a world where heat can exist without sunlight, where oceans thrive in eternal darkness. As you look at them, a quiet realization settles in. Every world teaches you something about what it means to be alive. Alien planets with thick atmospheres remind us how precious breath is, how each inhale on Earth comes easily, invisibly, beautifully. Frozen giants teach us the resilience of life and the way warmth can emerge from hidden places. Tidally locked worlds show that balance can exist between extremes, and that Twilight, the place between light and dark, can be a cradle for thriving ecosystems. Floating life in dense skies reminds us how adaptable existence can be, how life finds a way to rise, drift, and dance even when gravity pulls hard. We learn humility from these worlds, and we learn wonder. But we also learn something gently human. We understand ourselves better when we imagine what we are not. When we think of beings living in oceans beneath ice, we appreciate sunlight. When we picture organisms glowing softly in dark forests, we appreciate colour. When we imagine long days that last a lifetime, we cherish the rhythm of Earth's sunrise. When we consider worlds with multiple suns, we realise how special it is to have just one. Steady, reliable, familiar. These imagined worlds reflect our own internal landscapes too. Some parts of us feel like magma plains, warm, glowing quietly beneath the surface. Other parts feel like frozen oceans, still, deep, holding secrets, patiently. Some days we feel like twilight zones, balancing light and shadow. Other days we feel like worlds with thick atmospheres, wrapped in layers that protect us until we are ready to breathe openly again. And the silence between stars teaches us about the silence within ourselves. That quiet is not emptiness. It is potential. It is rest. It is the space where ideas form and emotions settle. Alien worlds also invite us to see Earth with tender eyes, to notice the way wind carries scents, the way water reflects the sky, the way leaves move when sunlight rests on them, the way your own heartbeat feels steady in your chest like a small star pulsing with life. In imagining distant planets, we rediscover our own, and in rediscovering our world, we rediscover ourselves, our curiosity, our vulnerability, our sense of belonging in a universe far larger than memory or fear. As you breathe softly now, let that realization drift through you like a warm current. The universe is vast enough to hold countless worlds, each with its own beauty. But only by exploring them in thought do we learn how deeply rooted we are in ours. Alien worlds expand our imagination. Earth anchors our heart. When we imagine distant planets, super-Earths wrapped in warm air, frozen giants hiding oceans, worlds glowing with bioluminescent forests, the question inevitably follows, will we ever go there? Humans are dreamers. We look up, we wonder, and we reach. But the journey between stars is long, so long that time itself feels different when you think about it. And yet, something in us continues to drift toward the unknown, as though curiosity were a quiet force of gravity pulling us outward. Imagine a far future, not tomorrow, not next century, but a time when humanity has grown into its patience, a time when spacecraft move not quickly but steadily, a time when voyages between stars feel less like missions and more like migrations, not fleeing Earth, but exploring gently, like stepping into a quiet forest for the first time. If humans ever walk on super-Earths, we will arrive carefully. Gravity will be stronger. Our bodies will need time to adapt. We might build habitats that blend into the environment, shaped to match the rhythms of a world not yet familiar. Our footsteps will fall softly, not from caution, but from reverence. Every rock, every breeze, every horizon will remind us how far we have travelled, how deep our curiosity runs. On ocean worlds, we may descend beneath ice into warm subsurface seas, drifting through water lit by glowing life. On tidally locked planets, we may settle in the twilight belt, where the constant glow of a star meets the eternal cool of night. On worlds with thick atmospheres, we may build floating cities, platforms suspended like quiet islands in warm, buoyant air. We may learn to grow plants beneath multiple suns, their leaves shimmering with colours shaped by alien light. We may learn to build structures that breathe with the weather, flexing gently with the world's slow winds. We may learn to listen to the soundscapes of new skies, to the deep hum of dense air, the sharp hush of thin atmospheres, the rhythmic cracks of expanding ice. But more than anything, we may learn something unexpected, that even among the stars we carry Earth with us, the rhythm of waves, the smell of soil, the memory of rain, the way sunlight filters through leaves, the way night feels before sleep. These memories become the roots we take with us, not to recreate Earth elsewhere, but to remember where we came from. Perhaps one day, children born on distant worlds will ask what Earth was like. They will grow up beneath sapphire skies, or under two suns, thinking those skies are normal, thinking those suns belong to them, and they will be right. Home is not only where you begin, it is also where you breathe, where you learn, where you love. Human futures among the stars will not be defined by conquest or extraction, as old stories often imagined. They will be defined by adaptation, by cooperation with the worlds we meet, by a kind of cosmic humility. To travel far is to listen deeply, to settle gently, to let each world teach us how to live upon it. As you breathe softly now, imagine yourself aboard a quiet starship drifting through the darkness, engines humming like a distant lullaby, starlight stretching across the windows in soft silver lines. You are not racing, you are drifting, just as humanity always has, one question at a time, one discovery after another. If we ever reach those alien worlds, it will be because we learned how to move slowly, how to appreciate difference, and how to carry wonder with us like a lantern in the dark. Long before telescopes, long before rockets, long before we knew what stars truly were, humans were already looking up. Something in us has always tilted toward the sky, toward the endlessness, the mystery, the quiet glow of distant suns. We looked up not because we needed to, but because we felt something there. A pull, a question, a gentle invitation. And even now, after centuries of science and discovery, that same feeling remains, perhaps even stronger. Why do we look up? Why does the night sky stir something so deep within us? Imagine yourself standing outside on a quiet night. The air is cool, the ground is still. Above you stretches a canvas of stars, each one so far away that the light reaching your eyes began its journey before you were born. The universe is vast beyond measure, trillions of worlds, millions of galaxies, distances so extreme that even light struggles across them. And yet in this moment, under this sky, you feel connected, not small, not lost, but part of something wide and beautiful. We look up because the sky reminds us that life is more than our routines, our worries, our hurried days. Out there, time moves differently. Stars are patient, galaxies drift in slow spirals, light travels quietly for ages. The universe does not rush, and when we gaze into it, neither do we. We also look up because curiosity is woven into us. We want to know what lies beyond the next hill, the next ocean, the next star. Exploration isn't simply a scientific impulse, it's an emotional one. A longing to understand where we came from, where we are, and where we might go. Even when the answers are faint or far away, the process of seeking brings meaning. It tells us we are alive, and yet there is another reason, softer, more human. Looking up gives us perspective. It reminds us that our difficulties, though real, are fleeting compared to the long arc of cosmic time. A problem that feels overwhelming under a ceiling becomes lighter under the sky. The universe holds our troubles gently by showing us their scale, not to diminish them, but to ease them. Astronomers sometimes say that studying the cosmos is like holding up a mirror. The more we learn about stars and planets, the more clearly we see ourselves, our fragility, our resilience, our capacity for wonder. When we imagine super-Earths glowing with hidden heat, or floating life drifting in thick air, or twilight worlds bathed in perpetual dusk, we're not only exploring potential planets, we're exploring potential reflections of our own spirit. We look up because the night sky is a kind of homecoming, a reminder of origins made of stardust, a reminder of possibility, worlds uncounted, a reminder of continuity, light travelling through time, a reminder of wonder, that quiet feeling rising in the chest, warm and expansive, impossible to explain but easy to recognise. As you breathe softly now, imagine lying beneath a wide, dark sky. The stars do not demand anything of you. They do not rush you. They do not judge or hurry or ask. They simply shine, steadily, quietly, patiently. And in their light, you feel something loosen inside you like a knot gently unwinding. This is why we look up, not just to explore the universe, but to explore ourselves. As we drift deeper into the quiet of the night, the mind begins to widen, stretching gently into the vastness beyond Earth. And in that widening, a soft truth appears. The universe does not dream in stars alone, it dreams in worlds. Planets are not rare jewels scattered sparsely across the dark. They're abundant, countless, woven into the fabric of the cosmos with surprising generosity. Wherever a star forms, worlds almost always follow. It is as though creation itself prefers to shape places, homes, havens, landscapes where matter can settle into meaning. Imagine a galaxy with hundreds of billions of stars. Now imagine that around most of those stars, planets orbit quietly. Large ones, small ones, icy ones, glowing ones, rocky ones, watery ones, ringed ones. The variety is staggering, almost poetic, and this is only one galaxy. There are trillions more. Even if only a fraction of those planets resemble super-Earths, tens of billions of them may exist, each with its own gravity, climate, chemistry, and personality. Cosmic abundance means that the universe is not empty. It is not quiet in the sense of being barren. It is quiet in the way a vast forest is quiet, full of life, full of secrets, full of growth happening slowly, invisibly, persistently. Imagine drifting through interstellar space in this quiet forest of worlds. Every few light years a new system appears, a glowing star surrounded by orbiting companions. Some of these companions are giant planets with swirling storms. Some are small, dark rocks. But many are super-Earths, planets larger and heavier than ours, potentially holding thick atmospheres, deep oceans, or rich mineral surfaces. They are everywhere, scattered like stepping stones across the galaxy. Cosmic abundance also teaches us something gentle. Life, too, may be abundant. Not necessarily life with cities or languages or tools, but simple beginnings, chemistry stirring in warm ponds, microbial colonies clinging beneath ice, drifting organisms glowing in thick air. Life does not need perfection. It needs opportunity, and the universe offers opportunity in overwhelming supply. In this abundance, something beautiful becomes clear. The universe does not hoard possibility, it shares it widely. No single world holds the monopoly on wonder. Not Earth, not the planets of our solar system, not the worlds we imagine in the distant night. Wonder is distributed like starlight, everywhere, in all directions, waiting to be noticed. Even planets that seem hostile, frozen giants, magma plains, tidally locked worlds, carry the seeds of stories we have not told yet. They remind us that nature does not limit its creativity. It paints with ice and fire, with gravity and chemistry, with silence and time. Every world is an experiment, a variation, a poem written in rock and air. As you breathe gently now, imagine the galaxy as a quiet library filled with billions of books, Each book a planet, each planet holding a unique story, some old, some new, some still being written. Our curiosity is the key that lets us open these books, even from afar, reading their atmospheres, their climates, their orbits, their light. Cosmic abundance is not overwhelming. It is comforting. It means we are not isolated. It means possibility surrounds us. It means the universe is generous with its creativity. And somewhere in that abundance, among countless stars and worlds, Earth drifts peacefully, not alone, not central, but part of a vast cosmic family. After wandering through so many imagined landscapes, twilight worlds, ringed horizons, glowing forests, oceans hidden beneath ice, a quiet truth begins to rise like a tide. All these planets, all these possibilities, all these suns and shadows and atmospheres, they are not separate from us. They are chapters of the same cosmic story that gave rise to Earth and to you. Imagine the universe not as a scattering of distant objects, but as a single unfolding narrative. Stars ignite, shaping the elements that form planets. Planets form, shaping landscapes that cradle life. Life emerges, shaping minds that can wonder. Wonder grows, shaping the urge to look upward, and here you are tonight, lying peacefully in your own corner of the galaxy, drifting into sleep while imagining worlds you have never seen. This ability to imagine, to create meaning, to connect with things beyond experience, is the bridge between worlds. It is what binds us to the stars. It is what makes us part of their story. Think of the atoms in your body. The hydrogen in your breath was born in the Big Bang. The carbon in your bones was forged in the heart of ancient stars. The iron in your blood was created in the explosive death of a supernova. You carry the universe within you, literally. The galaxies are not far away. They echo in your cells. Every world we've visited in imagination tonight is made of the same elements that made you. In this way, you belong not just to Earth, but to the wider cosmos. Now imagine all the worlds we've drifted through. The super-Earths, the glowing oceans, the tidally locked horizons, not as separate destinations, but as reminders of our shared origin. The same physics shaped them, the same chemistry, the same cosmic dust, the same natural laws that allow them to shine also allow you to feel, breathe, and dream. Even if life never arises on those worlds, even if their skies remain empty, even if their surfaces never know the touch of footsteps, they still add beauty to the universe. They complete the story. They enrich the cosmic tapestry with diversity, possibility, and quiet truth. And if life does arise elsewhere, if somewhere in a distant galaxy minds look up at their night sky and wonder, then those beings are part of this story too. They would be reflections of us, echoes of the same cosmic process, not foreign, not separate, but distant relatives in an ancient family. This unity is soft, not loud. It does not demand attention. It reveals itself in moments like this one, when the world is quiet, when night drifts closer, when your thoughts slow into calm. In these moments you can feel the thread that connects everything: stars, planets, life, awareness, wonder. As you breathe gently now, imagine yourself floating above Earth, watching it spin beneath you, its oceans shimmering, its clouds drifting, its nights glowing softly with human cities like small constellations. From this height, Earth looks like just one world among many, and yet it is the world where you learn to dream of others. The quiet truth is simple. We do not merely observe the universe, we participate in it. We are shaped by it. We are made of it. We are part of its story. After drifting so far across the cosmos, through glowing atmospheres, frozen oceans, ringed horizons, and silent interstellar planes, you may feel a kind of spaciousness inside yourself, a quiet you didn't know you were carrying, a softness shaped by the stars, and now, gently we begin the slow return home, imagine yourself floating in the dark between worlds. Behind you lie the countless planets we visited in thought, worlds warm and cold, bright and dim, peaceful and strange. Ahead of you glows a familiar star, the sun. Its light is softer from this distance, a warm pinprick in the dark. But you recognize it instantly, the way you recognize a comforting voice in a quiet room. That's home. That's where your story began. You start to drift toward it, not quickly, not urgently, but with the slow grace of a falling leaf. As you move closer, the constellations shift subtly back into their shapes you know from childhood. Orion's belt, the Pleiades, the arch of the Milky Way. They reassemble themselves like pieces of a puzzle returning to place, reminding your mind of its familiar sky. And then, further below, a small blue light begins to shimmer. Earth. It appears almost shy at first, wrapped in its halo of atmosphere, half illuminated by the sun, half resting in shadow. Oceans glisten, clouds drift in swirling white patterns, continents glow with the faint warmth of reflected sunlight. From here, Earth is not large or imposing, it is gentle. It looks like a cradle floating in the dark, carrying every memory you've ever held, every breath you've ever taken, every moment of joy and sorrow, learning and wonder. As you drift closer, details sharpen. You see the thin, delicate film of air that protects us. You see the curved horizon glowing in shades of gold and blue. You see night spreading softly across half the planet, city lights twinkling like constellations born on the ground. And then, without rushing, you imagine descending through the atmosphere. The air wraps around you like a warm blanket. The sky deepens from dark to blue. Clouds pass beneath you, billowing gently like soft white waves. You feel gravity settling into your body again, light at first, then familiar. You land somewhere quiet, perhaps on soft grass, perhaps near the ocean, perhaps on your own bed, waiting in the dim light of your room. Wherever you arrive, it feels like returning to yourself, to the body that carried you through this imaginative journey, to the steady rhythm of your breath, to the calm that has been building inside you. You realize slowly that even though you traveled across the universe in your mind, you never truly left home, because home is not only a place, it is a feeling, a grounding, a gentle return to the present moment. Earth may not have sapphire skies or floating forests or glowing oceans beneath ice, but it has birdsong and wind through trees and rain on rooftops and laughter and oceans that breathe against the shore. It has colours that feel familiar, landscapes shaped by time, and people who share your sky. It has warmth, life, and stories, and tonight it has your rest. As you take a slow breath, imagine Earth holding you gently, the way gravity always does, the way air always does, the way quiet always does when you allow yourself to sink into it. The journey is almost complete. You are here, you are safe, you are home. As we arrive gently at the end of this cosmic voyage, something quiet begins to settle. A sense of spaciousness in the mind, a softness in the chest, a calm that feels earned. You have drifted through star fields and glowing atmospheres, across frozen oceans and warm twilight plains. You have walked beneath ringed skies, listened to alien winds, and floated among bioluminescent forests. And now, as you lie here in the stillness of your own room, the universe feels both vast and intimate, distant and deeply connected to the breath moving softly in your body. It's easy to think of all those imagined worlds as far away, unreachable, belonging to telescopes and starships and distant futures. But in truth, they became part of you the moment you pictured them. Every world you visited tonight formed not only from cosmic physics, but from your own curiosity, your own openness, your own willingness to drift into wonder. These landscapes live within you now, not as destinations but as feelings, as reminders of how vast the universe is and how peaceful it can feel when you let your mind float gently through its possibilities. A slow inhale brings you back to the present. A soft exhale helps your thoughts settle, like stardust drifting into place. You may feel your body sinking deeper into your bed, the weight of gravity grounding you after so much imaginative flight. The air around you is calm. The night is quiet, the world is still, and in that stillness a gentle truth emerges. You don't need to travel across the galaxy to experience wonder. You carry the capacity for wonder everywhere you go, every time you pause, every time you look up, every time you let your thoughts slow into the soft rhythm of curiosity. The vastness you explored tonight is not outside of you. It's mirrored inside. The silence between stars echoes the quiet within your mind. The glow of alien bioluminescence reflects the glow of your own imagination. The balance of distant worlds reminds you of the balance your own heart seeks. Moments of brightness, moments of shadow, and the calm twilight between them where rest is found. As you breathe gently, imagine one last image, a star in the distance, glowing steadily, patiently. Around it orbit countless worlds, each holding possibility, each wrapped in its own unique beauty. And floating among them is Earth, your home, your grounding place, warm and familiar. The universe is large, but you are not lost in it. You are part of its story. You always have been. Tonight you travel through cosmic landscapes not to escape life, but to return to it more softly, with a quieter heart, a calmer breath, and a deeper sense of belonging to the vast, gentle web of existence. Now, as the final moments of wakefulness drift away, let these closing words settle into you like a lullaby carried on starlight. Everything flows. Sleep in that motion.